Okay, Bhuti. We can start today's class. First, we are going to do center of gravity part. I think we can finish that part within very few hours. Then we will do work and energy in our second session. Alright. Okay. Center of gravity. Actually, we have discussed most of the things in center of gravity. Bhuti. Finally, we have discussed how to determine the center of gravity of a combined object. In that case, you need to use principle of moment to determine the center of gravity of a combined object. Okay, so we have done that part. Then, right, the topic, right, the first topic of today's class would be this one, finding the center of gravity. Finding the center of gravity of an object after removing some part. Finding the center of gravity of an object after removing some part. Suppose now you are given this kind of object. And now you are given this kind of object with it. Now you are going to, okay, suppose now this is a rectangle with it. Suppose this length is 10 meters. And assume the weight of this rectangular lamina is 10 kg. Weight of this rectangular lamina is 10 kg. Now we are going to cut some part of this lamina. 10 meter, 2 meter. Suppose this is a uniform lamina, and I'm going to remove I'm going to remove 2 meter section from this lamina. So initially, actually, this is a uniform lamina. Therefore, initially, the center of gravity should be located at the center of this lamina. At the center means the center of gravity should be located 5 meter away from AD axis. 5 meter away from AD axis. The center of gravity should be located 5 meter away. 5 meter away from center of gravity AD axis and 2 meter away from DC axis. Okay. Therefore, that is the location of center of gravity initially. But now I'm going to cut some part of this lamina. That means I'm going to remove some part with it. So after removing that part, what would be the new center of gravity? What would be the new center of gravity? So actually, in this case, it is easy to determine because after removing this part, the shape will be a rectangle also with it. Therefore, we can take the center of gravity of that part too. But sometimes We cannot determine like that. And in that case, we need to determine center of gravity according to a special argument. Look at this one. Now, initially this object is A, B, C, D rectangle. Now I am going to remove B, C, E, F part. B, C, F part. Alright. Today, actually removing means actually, suppose now I have removed this thing. Suppose now I'm going to remove this part. So if I remove this part, then there will be two portions. There will be two portions. One is 8 meter long, other one is 2 meter long. Okay. So actually removing means addition of these two shapes, no? Isn't it? Removing means addition of these two. That means if you combine these two, you will have this shape. That means those two are the shapes. Those two are the shapes before combining. So after combining these two shapes, you will have this one, ABCD rectangle. That means, in the other words, that means if you combine these two, the resultant shape is this one. The resultant shape is this one. Yeah. Therefore, removing can be converted into combining. Remove combine. Therefore, removing can be converted into combine, because once you remove some part, you can reverse the process, no? That means if you add these two, then this will be the resultant shape. This will be the resultant shape. Like that. Then हर दे then हर दे समझ लग गया. Okay. What I was discussing, if you cut this lamina, you will have this kind of two shapes. On the other words, if you add or if you combine these two shapes, you will have the initial shape. That means the resultant shape, the result or combined shape of these two shapes is this one. Okay. If you combine these two shapes, you will have this one. And therefore, removing can be converted into combining. That means if you combine these two, then you will have this shape. You need to determine the center of gravity of this one. Make any center of gravity. You need to determine the center of gravity of this one. I don't know center of gravity. Suppose the distance from here is x bar. Distance from here is y bar. This is center of gravity. X bar. Therefore, center of gravity of this portion is x bar. I don't know this. I don't know the thing. So you know, this is a uniform lamina. This is a uniform lamina. Therefore, area is proportional to the weight. Area is proportional to the weight. So area here, area is 40. Area is 40. Weight means mass is 10 kg. Mass is 10 kg. Therefore, 40 square meter represent 10 kg mass. Now here is 82. 4 means 32. Therefore, 40 square feet, 40 square meter represent 10 kg mass. Therefore, 32 square meter represent 10 kg divided by 40 multiplied by 32. The answer is method 10 method 8 therefore 8 kg. Therefore, the weight or mass of this lamina is 8 kg. Therefore, rest of thing is 2 kg. This one is 2 kg. This one is 2 kg. You know this one. You know this one. Here 10 kg. This height is 2 meter. This height is 5 meter. And suppose you know the exact location of the center of gravity of this portion. And again, make it unknown. If you don't know, you cannot solve the question, Putir. At least you should know one center of gravity among these two shapes. And you should know either this center of gravity or this center of gravity. Otherwise, you cannot solve the question. Therefore, suppose you know the center of gravity of this portion. This is small portion. Now, center of gravity of this small portion is 1 meter from here to 2 meter. Now, look at this one. Actually, I have removed one part. Removing one part means combining these two into this one. Therefore, instead of removing, I can convert it into combining. Then, the resultant shape of these two is this one. Therefore, these two forces are the components of this resultant. Therefore, this is the resultant of these two forces. Is that clear? These two, actually, this 10 kg force is the resultant force of 8 and 2 kg forces. And now you can apply principle of moment to solve this question as we did earlier. අපි කලින් කරා වගේ අපිට use කරන්න පුළුවන් principle of moment. How do you use that? Now we can apply principle of moment about මොකද්ද මේක? මේක මම AD ද? AD EF. මෙතන EF BC. Mangana about AD. If I take moment about AD, 8 into x bar 8 into x bar plus මේ පැත්තට ගන්න. මෙයා මෙතන ඉඳන් මේ පැත්තේ ඉන්නේ. එතකොට if you combine these two එතකොට එන්නේ මොකද්ද? 2 into 8 plus 1 meter. මෙතන අපිට 8 නේ 8 plus 1 meter එක හැදෙන්නේ නෙමෙයි. Actually this object form like this one. Now from here to here with the 8 meter, from here to here 8 meter, from here to here 1 meter. From here to here 1 meter. Therefore, from AD to this location distance is 8 plus 1, 9 meter. 9 meter. This is equal. This is those are the resultant moment. Resultant moment is equal to the moment of the resultant force. Moment of the resultant force is 5 into 10, 50. 5 into 10, 50. And බලන්න පුතේ, that means x bar right? 5 into 10 දාන්න. Therefore, it is very clear 8 into x bar is equal 5 into 10 minus 2 into 9 put it 5 into 10 minus 2 into 9. If it is clear, please raise the hand. තේරුණා තුස්සන්නේ කියලා. තේරුණා තුස්සන්නේ. If it is clear, please raise the hand. තේරුණා තුස්සන්නේ. Yes, Femi. $80 Newton means resultant. No, actually, I didn't convert kilogram to Newton. I did not convert kilogram to Newton because 10 to 10 will be cancelled out of that. Therefore, I did not convert kilogram to Newton. Okay. No. This is the combined object. This is the combined object. Actually, I have separated this to there. Actually, after combining, this is the object to there. After combining, this is the object. These are the two shapes. These are the two shapes. This suppose this one is A, this one is B. ඒ වදින්නකො නැත්නම් ඕගොල්ලෝ ඕක පටලව ගන්න. අම්මෝ. ආපේ හොඳයි. ආපේ හොඳයි නැත්නම් ඕගොල්ලෝ පටලව ගන්න. Okay. Actually, now there are two shapes. Suppose now there are two shapes today. This is A, this is B. If these two shapes, if you glue them or if you combine them, then you will have this shape. Is that clear? Is that clear? If it is clear, please raise the hand. ඔයාලා මේක glue කරොත් මේක එනවනේ නේද? If you glue them, then you will have this shape. Is that clear? Right. Now I'm going to prepare a combined shape. Let's do it. This shape is A, this shape is B. This shape is A, this shape is B. And therefore, you know the center of gravity of this shape. the center of, I don't know center of gravity with this shape. Okay? But then a wala shape mega. Therefore, this one is 8 kg. This length is x bar. This length is y bar. I don't know that now. Then you know the center of gravity of this object. This is 2 kg. From here, the center of gravity is 9, but from here, it is 1 meter. From here, it is 2 meters. It is 2 meters. So this is the center of gravity of portion A. This is the center of gravity of portion B. So once you combine these two, the center of gravity, the center of gravity of entire object, comes to this portion. This is 10 kg. This is 10 kg. 10 kg. From here to here, distance is 5 meter. From here to here, distance is 2 meter. Is that clear now? Is that clear now? May figure it. If this figure is okay, please raise the hand. Everyone I need responses. Everyone I need responses. Still you cannot get this figure. Please let me know. Oh. Oh, it will get it. Look at this. Everyone please listen to me. This is the center of gravity of portion A. This is the center of gravity of portion A. I don't know the place of that center of gravity. Therefore, I have mentioned it as X bar and Y bar. Is that clear? If it is clear, please raise the hand. Uday, please give me a response. නැත්තම් මට කියන එක ප්‍රශ්නයක් නෑ. මම මේ A වල මාක් කරපු එක තේරෙනවද? Oh. What is 4 පුතේ? Actually, in this case, you don't want to find the center of gravity in this in this scenario. Actually, center of gravity can be taken as 4 into 2. 4 to location. No need to solve that thing. But that is not my case. That's why I explained that to you. Suppose if you are given this kind of shape, and this kind of from this shape, this kind of shape is removed. Then how to do? So that is my final objective. That's why I want to teach you how to do that. They are actually no need to calculate this one. You can do without calculation. Because this is a uniform lamina. This is a uniform lamina. Therefore, center of gravity should be definitely 4 to 2. 4 to 2. Okay? That's okay. Now I'm going to prove that one. I'm going to prove that one. Because you are not given this kind of easy questions. You will be given this kind of questions. Therefore, you have to understand how to do. Okay? Is that clear now? Harry, now tell me, this is the center of gravity of portion A. I don't know whether the center of gravity of portion A. I don't know. That's why that is my question. That is my question. What is the question? After removing this part, after removing part B, after remove part B, the remaining part is part A. What would be the center of gravity of part A? That is the question. You have to determine center of gravity of part A. And part B is a standard shape. Part B is a standard shape. Therefore, you know the center of gravity of that portion. Okay, like this. Okay. So this is a square put there. This is a square. From that square, this kind of circle is removed. Therefore this is the part B. So part B is a standard shape. Therefore, you know the center of gravity of part B, removed part. You know the center of gravity of removed part. Therefore, you know the center of gravity of removed part. That is 1 meter from here and 2 meter from here. The weight is 2 kg. You know that thing. Is that clear? You know that thing. You know the center of gravity of removed part because that is a standard shape, the standard geometrical shape. So after removing the standard geometrical shape, now you have a shape. Actually, this shape is not any standard shape. Make standard shape and this is not a square, this is not even a circle. This is a square, and from that square, a circle shape is. Therefore, this is not a standard shape. Therefore, you cannot determine whether the actual center of gravity is where the actual center of gravity is located. Okay. Therefore, my objective is how to determine center of gravity of this kind of shape. And in that case, you don't know the center of gravity of final shape. That's why I mark it as unknown parameters. That's why I mark it as unknown parameters. Then you know the center of gravity of remove part because it is a standard shape. That's why I mentioned it as 1 meter and 2 meter. Because I know that thing. Then you know the center of gravity of the standard object before removing the part. That means initial this was a square root. Therefore, you know the center of gravity of the object before removing the part. That's why I mark the center of gravity of the entire object from 5 to 2 location, and center of gravity mass is 10 kg. Mass is 10 kg. Is that clear now? Is that clear now? If it is clear, please raise the hand. තේරෙනවා නේද උස්සන මට ඕනි මෙන්න මේ වගේ කතන්දරයක් කතා කරන්න. මේ වගේ කතන්දරයක් කතා කරනවා මට. Is that clear? මට මෙච්චර මේ නටන්න ඕනේ මේකම මම කතා කරන්නම් පුතේ. නැත්තම් ඕගොල්ලෝ ඔක මට තාමත් ෂුවර් නෑ ඕගොල්ලෝ බටලව ගන්නවද කියලා. හරි මම හරියම දෙයක් කතා කරන්නේ. නැත්තම් මේ මම අර වැඩිපුර ලේසි දෙයක් කරන්න ගිහිල්ලා ඕගොල්ලෝ ඔක බටලව ගන්නවා. මම මේකම කතා කරන්නම්. Suppose now there's a square. Now there's a square. One side is 10 meter long and weight is 10 kg. 10 kg. Then from that square, okay, This kind of shape is unique. Therefore, this kind of shape is unique. This kind of shape is unique. Here we shape back removal. So now you have this kind of shape. So this is the final shape. Now you are asked to determine what is the center of gravity of this final shape. What is the center of gravity of this final shape? What is the center of gravity of this final shape? And what? අපි weight එක දාමු. දැන් අපි weight එක හිතන්න එතකොට මම weight එක විතර මම remove කරලා තියෙන circle එකක් නෙමෙයි. I have removed circle therefore without considering weight we can do this. Suppose this weight is W. The entire weight is W. This part is I'm gonna make W total W total. This part is W1. W1. Therefore, weight of this part is WT minus W1. Weight of this part is WT minus W1. weight එක දැම්මම weight එක දාන්න ගියොත් එහෙම දැන් ඔය කියන මේ අර area එක consider කරලා හදන්න ඕනේ. ඒක හදාගෙන ඉන්න එක වෙලා යන නිසා මම නිකන් value එකක් විතර දානවා. හරි. Okay. So you need to determine the center of gravity of this one. Center of gravity of this one. And therefore, I don't know the center of gravity of this part. Suppose this one is x bar and this one is y bar. You need to determine the center of gravity. I told this is the final object. Now this is the final object. And actually, if you combine this object and this object, then you will have the initial object. if you combine this object and this object, you will have the initial object. Therefore, if I draw this one, this is W1 put A. So W1 should be, this length should be 5 meter. Sorry, this should be 5 meter. Please, I'm going to do it again. 12 meter, therefore, this one is 6 meter. The total length is 6 meter. Therefore, this length should be 3 meter. May length is 3 meter. May length is 3 meter. So this length, the entire length is 12. This height is 6 meter. This height is 6 meter. A, B, C, D. So that is the location of the center of gravity of this circle. This circle. Then the center of gravity of this object, I don't know that thing. Here, Wt minus W1. The location is x bar y1. The location is x bar y1. And now I have combined this object. I have combined this object and this circle. Once you combine these two, you will have this. You will have this. Therefore, once you combine these two, then the resultant weight should be located at this position. That is Wt. That is Wt. Therefore, Wt from here to here, this length is 6 meter. This height also 6 meter. Therefore, that is the location of Wt. Is that clear? Therefore, if I mark these forces, these forces are like this. මෙතන නම් පුතේ x bar කියලා distance එකෙන් තියෙනවා Wt minus W1. Then Wt is at 6 meter away. 6 meter away from this. Okay? Wt is 6 meter away. Then W1 is 9 meter away. W1 is 9 meter away. That is the distance from AD axis. Then the distances from AB axis all are located 6 meter above. All are located 6 meter above. Is that clear? තේරුණාද ඒක? පැහැදිලි නම් අපි උස්සන්නේ. දැන් මේක තේරුණා නම් උස්සන්න. I need responses from everyone. අපිට හැමෝගෙම respond එකක් දෙන්න පුළුවන් නම් වඩා හොඳයි. Linit, Christian, Yasit. Actually, removing means, on the other hand, combining. Okay? Combine. Therefore, this is the weight of this circle. This is the weight of this part. This part means after removing the shape of the geometrical shape. Then if I combine these two, I will have this object. Okay. Then I can mark the distances from AD and B and from AB to the center of gravities of each object with it. Sorry. Then it is very clear WT is the resultant force of WT minus 1 and W1. This is the resultant force of these two. Therefore, you can apply principle of moment with from AD and about you can apply center of sorry, you can apply principle of moment. You can apply principle of moment around AD and around AB to determine x bar and y bar. To determine x bar and y. Is that clear? තේරුණාද මම කියන්නේ? තේරුණා මම කියන්නේ? Okay. මේ right this one. මේක ලියා ගන්න. මේක ලියාගෙන මේක අඳ ගන්න ඊට පස්සේ මම ඉතුරු ටික ගන්න. Suppose that's a square. A circular part is removed from this square. We need to determine the center of gravity of we need to determine the center of gravity of the final object after removing the circular part. No. You have to write this one. Again, I will repeat. Suppose there's a square. A circular part is removed from this square. A circular part is removed from this square. We need to determine the center of gravity of the remaining object. We need to determine the center of gravity of the remaining object. We need to determine the center of gravity of the remaining object. We need to determine the center of gravity of the remaining object after removing the circular part. After removing the circular part. Okay, try to another para. If we combine The remaining shape and the circular portion, if we combine the remaining shape and the circular portion, we will have the initial object. We will have the initial object. Therefore, the initial weight, the initial weight is the resultant of therefore the initial weight is the resultant of the weights of the weights of the remaining part and remove part. Remaining part and removed part. So therefore we can apply principle of moment. We can apply principle of moment to solve this question. Okay, now you can draw this one. Very good question. Very good question, Desalu. So that is because, Maran, what question I can answer? Very good. Okay. Bad question. That is very good question. Can anyone answer that question? How did I say? Y bar. Y bar is 6 meter above 6 meter above the AB line. You know, actually, you don't need to consider that part. ඒක හිතන්න එපා. ඒක අපි පස්සේ කියන්නම්. ඒක හිතන්න එපා. වේදක විතරක් ගන්න. This is Y bar. This one is 6 meter above. This one is 6 meter above. This length is X bar. Y bar කියලා. එතන 6 meter බෝ කියලා දාගන්න එපා. Y bar කියලා දාන්න. මම ඒක පස්සේ කියලා දෙන්න 6 meter එන්න පුළුවන් නම් වෙන්න කොහොමද කියලා. 6 මීටර් එන්න පුළුවන් නම් ඒක එන්න හොයන්න කොහොමද කියලා මම කියලා දෙන්න පස්සේ. දැන් ට්‍රොයි බාක් කියලා තමයි. Hello, Buddhi. I have computed. Shall I erase? Shall I erase? Okay. Now I apply center of principle of moment. Principle of moment about AD. Principle of moment about AD. Further, if I apply principle of moment about AD, x bar into WT minus W1. This is one force, but this one is other force. This is one force, this one is the other force, this is the resultant force. This is one force, this is the second force, this one is the resultant force. Therefore, moment of the first force plus moment of the second force. All lie to the same direction, therefore plus W1 into diameter is equal WT into 6. WT into 6. Is that clear? If it is clear, please raise the hand. If it is clear, please raise the hand. I need responses from you. I need responses from you. If this is clear, please raise the hand. This is the moment. This is the moment of this force about AD. This is the moment of W1 about AD. Those are the two forces. This is the resultant force. And therefore, I can write this one as this is the moment of remaining portion. This is the moment of remaining portion. But then this is the moment of removed portion. Moment of removed portion is equal. This is the moment of the entire object. Moment of the entire before removing. Is that clear? Moment of remaining portion plus moment of removed portion is equal moment of entire object before removing. Is that clear? If it is clear, please raise the hand. Hey, Uranathu-san. If it is clear, please raise the hand. I need responses from everyone. Everyone. Right. Therefore, you need to determine this one. Okay, you need to determine this one. Therefore, moment of remaining portion, moment of remaining portion is equal to moment of the entire object before moving minus moment of remote force. Moment of remote force. Portion. Moment of remote portion. Therefore, moment of the remaining portion. Actually, you need to determine this one with the moment of the remaining portion. moment of the remaining portion is equal to the moment of the entire portion before removing minus removed portion, moment of the removed portion. Is that clear? තේරුණා තුස්සන? තේරුණා තුස්සන? If it is clear, please raise the hand. So this is the way how we are going to determine the center of gravity of remaining portion after remove some part of it. So this is the way how we are going to determine the center of gravity of a remaining portion after remove some part. So how to determine the center of gravity? You have to take the moment of the entire object before removing minus moment of the remove portion about the same axis, so about the same point. About the same point. About the same point. About the same point, you know. About the same point or axis. මේක දාගන්න ඉතින්. Or with the half finish. Half finish. Shall I rest? Okay. Okay, Puti. Okay. When we are determining center of gravity, please listen to me, everyone. Everyone, please listen to me. So when you are determining center of gravity of a combined object or remove part, you have to consider this one. You have to consider this one. Suppose, so these are symmetrical axes, okay? So this is a diameter. This is the diameter of this circle. Therefore, this is the center. This is the center of the circle. This is the center of this circle. Therefore, weight of this one is W1. You know, total weight is W T, that is here. Pute, here there are three parallel forces to Pute. There are three parallel forces. One, actually, there are two parallel forces. The third one is the resultant force of the. There are two parallel forces, W1 and WT minus W1. That is the resultant force of these two. Suppose you are given this kind of scenario. So this is force P, this is force Q, then this is the resultant force of P and Q. This is the resultant force of P and Q. So you know, as these three forces are parallel forces, this A, B, and C, point of actions are collinear. This A, B, and C point of actions are collinear. Therefore, if you know the point of actions of two forces, the point of actions of other force should be on the line of these two points with the line connecting these 2 points. Is it clear? Okay. As these three forces are three parallel forces, these A, B, and C points are collinear. This A, B, and C. C points are collinear. Is that clear? If it is clear, please raise the hand. මේ වගේ parallel force තුනක් ගත්තොත් ඒකේ resultant එක තමයි පුතේ මේ තියෙන්නේ. එහෙම නම් මේ points තුනම එකම line segment එකේ ඉන්න ඕන කියන එකට තේරුණා තුස්සන්න. If it is clear, please raise the hand. If these two forces are parallel to each other, then this is the resultant force. Therefore, the point of actions of these three forces should be lie on the same line. Is it clear? If it is clear, please raise the hand. Okay, thank you. Then come to this one. So you know this one is a parallel one, this one also parallel one. Therefore, here one point of action, here the second point of action. So you know these two points are point of actions. Therefore, the third force means the weight of the other object. The weight of the other object should be exerted somewhere on this line, somewhere on this AB line. And so in this case, I mark that one as E. Because these two forces are the forces to put. This is the resultant force. Therefore, resultant force should be in between W1 and other force. The resultant force should be in between W1 and other force. Therefore, the other force should be left to W2, WT. The other force should be left to the WT put it. Therefore, here WT minus W1. Therefore, these A, B, and C lines, A, B, and C points, these A, B, and C points should be collinear forces, collinear points put it. Those should be on the same line. Okay, I will explain it again. Everyone please listen to me. So if you are given this kind of force system, that means parallel force system, if you are given parallel force system, you know this thing. If you are given this kind of parallel force system, these two are the forces. This is the resultant force of P and Q. You know, AB to BC ratio is equal Q to P. AB to BC ratio is equal Q to P, as well as AB and BC lines, A, B, C points should be on the same line. Okay. And A, B, and C points are collinear. Collinear means they should be on the same line. And අපි parallel forces තුනක් ගත්තොත්, parallel forces දෙකක් ගත්තොත්, ඒ parallel forces දෙකේ resultant එක අනිවාර්යෙන්ම පුතේ add කරන්න except වෙන්නේ කොතනද? අර parallel force දෙක combine කරන line segment එකේ අතරමැද කොහේ හරි තමයි except වෙන්නේ. අපි ඒක prove කරලා තියෙනවා. Therefore, if there are two parallel forces, the resultant force of them should be in between them, and its line of action should be on the line segment, which is connected these two points. Which connects these two points. Is it clear? Parallel force දෙකක් තියෙනවා පුතේ. parallel force දෙකේ resultant force එක දෙන්න අතර මැද යන්න ඕනි. මේ තියෙන ratio එකට යන්න ඕනි. ඒ වගේ මේ වාගේ line of point of actions එකම රේඛාවක් තියෙනවා. එකම මේ ගන්න line segment එකේ තියෙනවා. ඒක මතක නම් තේරුණා නම් නේ මතක නම් අත උස්සන්න. If it is clear, please raise the hand පුතේ. තේරුණා අත උස්සන්න. මතක නැන්ද කට්ටියට මේක අපි කරලා ඉවරයි හොඳේ මේක අපි ප්‍රූව් කරලා මේක උඩක් කරලා කොහොමද ගාන්ධි දිනෙත් හරිද Suprema Shiv Prasit, is it clear? Actually it's not easy. Do you remember this thing? So, if there are two parallel forces, their resultant force should be in between them, and point of actions of three forces should be collinear. It should be collinear. Then, so if you can convert this knowledge into this case, Pute. So if you know 2 points of actions, it can either be this AB or BC or AC. If you know any two point of actions, then the other one should be on the line segment that connects the other two. No, that means if you know AB, if you know the point of actions of A and B, then C should be somewhere on this line, somewhere on this line. And you have determined what is the exact place today, but it should be somewhere on this line. And if you know A and C, then the B should be somewhere on this line. Somewhere on this line. Therefore, if you know two of them, the third point should be on the line segment that connects the first two. Therefore, if you come to this question, Pute, you know the point of action, the center of gravity of W1, that is A. You know the center of gravity of the bigger one, that is B, Pute, center of gravity of WT, that is B. Therefore, the other center of gravity should be on the line segment of AB. AB line segment එක තමයි මේක තියෙන්නේ. And somewhere on the AB. Then you can determine this is the resultant force. This is the resultant force. Therefore, resultant force should be in between the other two forces. Therefore, the other force should be left to WT. It should be left to WT. Because W1 is right to WT. Therefore, this force should be left to WT. And therefore, WT minus W1 should be exerted on extended AB line segment at point C. Is that clear? If it is clear, please raise the hand. ඔක තමයි ලෙසුදු වාගේ question එකට answer එක. ඔක තමයි ලෙසුදුගේ question එකට answer එක. කොහොමද 6 කියලා ගත්තේ y bar ගන්න නැතුව කියලා හෙව්වේ. හරිද 6 කියලා ගන්න පුළුවන් හේතුව මෙයා 6. මෙතන මෙතනට උස මෙයාගෙත් 6. මෙයාගෙත් 6. එහෙනම් මෙයාගෙත් 6 වෙන්න ඕනේ පුතේ. මෙයා වෙන කොහෙවත් ඉන්න බෑ. මොකද මේ තුන් දෙනාම එකම line එකේ ඉන්නවා. මේ තුන් දෙනා එකම line එකේ ඉන්නවා. ඒ නිසා මෙතනට උස 6 නා. මෙතනට උස 6 නා. මෙතනට උස 6 වෙනවා. ඒ නිසා y bar කියන එක හොයන්න දෙයක් නැහැ 6. Y bar කියන එක හොයන්න දෙයක් නැහැ 6. Therefore, if the center of gravity, if the point of action of W1 is 6 meter above this line, and if B is 6 meter above this line, then definitely C should be 6 meter above this line. Because all A, B, and C should be collinear. All 3 points should be collinear. Is that clear? If it is clear, please raise the hand again because I want to clarify that thing. So, මේක තේරෙනවා නම් තුස්සන්න පුතේ මේක ගොඩක් වෙලාට ඕනේ නෑ MCQ questions වලට. Issue, is that okay with you? හරිද? සුබම. Okay. Thank you. Okay, now you can write this one as a note. This one as a special note. Draw this one. A comma B comma C points are collinear. Therefore, if we know any two points, the other points should be located in the line segment Okay, let's do the following questions for them. By this question, find the center of gravity of the following objects. Find the center of gravity of the following objects. Okay. Okay, but here there's a 2R. Here there's a circle which has a radius of 2R. Then from that large circle, a circle that has a radius of R is removed. Then you have to find the center of gravity of the remaining circle. Then the same thing is done here, but after removing that R circle, it is connected again as in the figure. Here O1, O2, O3 are the centers of the corresponding circles. These three centers are collinear. Then third one. So that is the third question. That is the third question. Again, ABCD. ABCD is a square material. ABCD is a square. Now, from this square, this ABC, this VOC portion is removed. Then again it is connected to the same square as BDC. Make a line and then you are asked to determine the center of gravity of the final object. Center of gravity of the final object. Fine. Okay, let's do it. Once you did the questions, please send your answers to me. Please send your answers to me. One. Okay. Have you finished with it? Okay. Okay, I think first question was done by most of the students. Okay, let's see. So this radius is 4r, and sorry, 4r, not 2r. Radius is 2r. This one is r. This one is r. Therefore, no need to determine the area Pute. Because the area of a circle, directly proportional to the square of the radius. Square of the radius to Pute. So here r, here 2r. That means area is r squared, 4r squared, 4 to 1. Therefore, the ratio of area, should be 4 to 1. Is that clear? No need to determine the area, because you know how to get the area. Area is directly proportional to square of radius. Square of the radius. Therefore, if you consider this weight is W, then this one should be 4W. This one should be 4W. And no need to consider the area, no need to determine the area and density, or no need to consider the density. Yeah, if it is considered, it is not a error, it is not a error, it will be much better. But in most of the cases, these kind of questions are in MCQ paper. Therefore, no need to consider, no need to determine the area. If you can determine the ratio between the area, then take the smallest area as W, then with respect to W, you can determine the other weights. Is that clear? Is that clear? You can get the weight, you can take the weight of the smallest object first. As the smallest, you can take the weight of the smallest object as W, then with respect to that one, you can take the weight of the other objects. And is that clear? If it is W, this one is 4W. Then other thing is 3W to put the 3W means remaining part. Definitely this should be the 4W means it is the resultant force of W and 3W. Therefore 3W cannot be in here. It should be left to the 4W. It should be left to the 4W. Definitely should be left to the 4W. Therefore 3W should be here. TW should be here. Therefore, it is very easy, Pute. Therefore, this ratio should be 3. This ratio should be 1. This ratio should be 3 to 1. 3 to 1 ratio. Ratio should be 3 to 1. Ratio should be 3 to 1. Therefore, you know this length is R. You know this length is R. Therefore, this should be R over 3. This should be R over 3. This should be R over 3. 3 to 1. And therefore, the answer is R over 3 from this side, 2R minus R over 3. 2R minus R over 3. That means 5R over 3. But without writing any single word, you can take the answer. You can take the answer. Did you get my explanation? Okay, I will explain it again. Did you get my explanation? My explanation is theory check it to son at the master. Okay. Again, cut your blood. Okay. Bionic explanation එක දෙකට ඕනේ. හරි බලන්න. Okay. බලන්න. The first thing. Now there's no weight to it. Weight is not given. And weight is directly proportional to area. Because those are laminas. As I mentioned in the question, this is a circle, not a sphere. Therefore, those are laminas. Therefore, weight is directly proportional to area. I think most of the students may taken that part. And you understood that part. And the weight is directly proportional to area. If it is okay, please raise your hand. Weight take an area proportional. Then how to determine the area of a circle, Puti? How to determine the area of a circle? 5R squared. 5 is a constant. Therefore, no need to worry about 5. Area is directly proportional to R squared. Is that clear? If it is clear, please raise your hand. Area का R squared proportional to the I need response from everyone. Then you know the radius of this small circle is R. Radius of this bigger circle is 2R. Therefore, the ratio between arms, one is R, other one is 2R. Therefore, area should be proportional to one is R square, other one should be 2R squared is 4R squared. One is R squared, other one is 4R squared. Therefore, if I take the weight of this object as W, the entire weight of this bigger circle should be 4W. Because the ratio between areas are 1 to 4. The ratio between area is 1 to 4. Therefore, the ratio between weight should be 1 to 4. Therefore, if I consider the weight of this small object is W, the weight of this bigger circle should be 4W. If it is clear, please raise the hand. I need response from everyone. ඒක තේරුණා තුස්සා. එකක් W වෙනවා නික 4W වෙනවා කියලා තේරුණා. තේරුණාද ගෑනි? තේරුණාද? ඊනත්? සුප්‍රමා? කුෂි? තේරුණාද නැත්නම් කියන්න මම අසල කියලා දෙන්න. මායි ගත්ත එක තේරුණා නැත්නම් කියන්න මම එකපාරක් කියලා දෙන්න. මම හිතෙන් ගන්න ඕගොල්ලන්ට මම MCQ කරන්න try කරන්නේ. මම හිතෙන් ගන්න MCQ කරන්න try කරන්නේ. Is that okay? හරි මම මේක ලියන්න. පුතේ බලන්න. area of the දැන් හිතන්න මේක A මේක B නේද මම ගත්තේ. What is the area of A? What is the area of A? Area of A කියන්නේ බලන්න. Five R squared. No, is that clear? Area of the A is equal 5R squared. Harry, what is the area of B? What is the area of B? Area of the B is equal 5. Here R is 2R. No, 2R squared. 2R squared means 4 5R squared. Huh? මෙයාගේ area එක 5R squared. මෙයාගේ area එක 4 5R squared. Therefore, ratio between area is 1 to 4. 1 to 4. Is that clear? Is that clear? The ratio between area is 1 to 4. Therefore, the ratio between weight should be equal to 1 to 4. The ratio between weight should be equal to 1 to 4. Or otherwise, you can take the density of one material is rho. Then, the weight of this object is rho, sigma or rho 5R square. This is 4 rho 5R square. Again, 1 to 4. And therefore, no need to worry about that thing. And the density එක හොයලා හැමෝම යන්න ඕනේ නැහැ. එක මම එක මෙතඩ් එකක් මම කිව්වා. නමුත් හැම වෙලේම අපි මේ මෙතඩ් එකටම ඉන්න ඕනේ නැහැ පුතේ. මේ දැන් එතකොට මෙයාගේ weight එක W නම් එහෙනම් මෙයා total weight එක පුතේ 4W වෙනවා. 1 to 4. And is that clear? If it is clear, please raise the hand. I need responses from everyone. I need responses from everyone. Steve? You got the name? Suprema? Hadapute? Okay. Therefore, the weight of the bigger part is 4W, weight of the small part is W. Therefore, if I remove W part from 4W part, the remaining portion is 3W. Remaining portion is 3W. Therefore, 3W should be left to 4W because these two are the forces. This is the resultant force. Resultant force should be in between two forces. And the resultant force should be in between two forces because these are parallel forces. Parallel force if we take two parallel forces, the resultant force in between two forces. The ratio is 3 to 1. The ratio is 3 to 1. And resultant force, sorry, parallel force P to Q. So, resultant force, definitely resultant force should be in between them. The ratio between these two lines is P to Q. We know that. Therefore, you know this is the resultant force. This is the resultant force. This is one force. Therefore, the other force should be left to 4W. You cannot mark it in here. Is that clear? The 3W force should be left to 4W. If it is clear, please raise the hand. If it is clear, please raise the hand. I need responses from everyone. Thank you. Very good. Then it is very clear. Now there are three forces. One is put a 3W, other one is W. The resultant force is 4W. Now it is very clear. The ratio should be 3 to 1 put a. the ratio should be 3 to 1. But you know this length is R. This length is R. Therefore, this length should be R over 3 because 1 to 3. මෙයා 3ක් එන මෙයා 1ක් එන මෙයා 3ෙන් බෙදෙන්න ඕන. Therefore 1 3. We 3W came to take. Now 4W means that is the weight of the entire circle. Now from the entire circle, W part is removed. W part is removed. Therefore, the remaining weight is 3W. The remaining weight is 3W. Is that clear? You need to determine the position of 3W. You need to determine the position of 3W. Is that clear, Stu? Clear or not, Stu? Therefore, 3W is here, W is here. Therefore, center of gravity should be located 3W from the initial center. Or 2R, sorry, 3, sorry. Therefore, center of gravity, CG. CG should be B or not. CG location is B or is equal RO3. Or from other side, AB got to thema, AB from AB got to thema, 2R minus R over 3, that means 5R over 3. 5R over 3. So they get correct. Make it another question. If you got this one, please raise the hand. If you got my calculation, please raise the hand. My calculation is another. I need responses from everyone. Need it? Or if you need any clarification, please let me know. If you need any further clarification, please let me know. Okay. Then write a review for this one. I will use some note. Organize this one. Last part, you will make this one. Look at this one. Now, the bigger circle, the weight of the bigger circle is 4W. The weight of the small circle is W. Now this W part is removed. W part is removed. If the W part is removed, the balance, the remaining weight is 3W. Remaining weight is 3W. Is that okay? You need to determine the place of the remaining weight. Remaining weight. Place of the remaining weight. As I mentioned you earlier, instead of removing, you can consider it as a combination. And therefore, you can think this one as a combination between 3W and W. And make up with 3W here, minimum figure minimum figure 3W minimum figure may figure may circle like attach karawa. If you attach this circle into this 3W figure, then you have the bigger circle. And therefore, this is W put a, this 4W means that is the resultant force of W and 3W. W and theta. W and theta. 4W means that is the resultant force of W and 3W. Therefore, 3W should be placed left to 4W. Because you know, if you consider about two parallel forces, its resultant force is in between them. Resultant force is in between them. That means the resultant force is 4W. Therefore, 4W should be in between 3W and 4W. For 3W and W. Now you know the place of W. Therefore, 3W should be left to 4W. Is that clear? Is that clear? පැහැදිලිද? මේක 3W කියලා කියනකොට මෙන්න මේ කොටසම. ඒ කියන්නේ 3W කියලා කියන්නේ දැන් අපි මෙහෙම තියෙන්නේ. මෙන්න මේ හැෂ් කරපු එකේ weight එක තමයි 3W කියලා කියන්නේ. හැෂ් කරපු එකේ weight එක. මේක තමයි අපි මේ හොයන්නේ. මේකේ location එක තමයි හොයන්නේ. හරි. 3W should be at this location. ඔය හැෂ් කරපු එකේ weight එක. Is that clear? පැහැදිලිද? මේ හැෂ් කරපු එකේ weight එක පුතේ. Then W means that is this red color one. W means this is red color one. If you combine this black color one and red color one, if you combine this black color one and red color one, you will have the entire circle. You will have the entire circle. Okay? The entire circle, the weight is 4W. The 4W exerted at this location. Is that clear now? This is the red color one. Red color one has simple W weight. Black color one has 3W weight. Altogether 4W weight. That is a resultant weight today. If you combine the black color one and red color one, you will have the entire circle, full circle, biggest one. And therefore, the center of gravity of the biggest one exerted at this position. Therefore, you know the location of the resultant force. You know the location of one force. You have to determine the location of balance force, the balance object, remaining object. Is that clear now? If it is clear, please raise the hand. Now, these three forces are these two forces are two parallel forces. This is the resultant force today. Therefore, their line of action should be divided in the ratio of 3 to 1. Make about the 3 to 1. Therefore, this part is 3, this part is 1. Therefore, you know this length is R. මේ length එක R කියලා දන්නවා. Therefore, මේ 3 කියන එක මේ 3 කියන එක තමයි R කියන්නේ. Therefore, 1 means you have to divide R by 3. Divide R by 3. මෙයා 3 වලින් විතර තමයි මෙතනට එන්නේ. මෙයා 3 වලින් divide කරලා තමයි මෙතනට එන්නේ. Therefore, location is R13. R13. Is that clear? If it is clear, please raise the hand. There on to Sunday. This is black color one. You know the weight of black color one should be TW. Then if you combine the black color one and the red color one, then weight of the red color one is W, and the result, if you combine these two, you will have the entire full circle with 2r radius. Therefore, each center of gravity is located at this position. The weight is 4W. 4W is the result force of these two. Therefore, now there are two forces like this. This length is there. Now, suppose this is A, B, O, and D here. Therefore, if I draw this one like this, here A, whether they have the B, PW. 4W is the result force. Then this should be W. B or D. You know, OD length is R. OD length is R. Okay, now you can apply the principle of moment around point O, or you can simply take the ratio. This is 3 to 1 with the ratio. 3 to 1 ratio. Therefore, this should be R over 3. It should be R over 3. Or otherwise, if you can take this one as x bar, therefore x bar, if you take moment for the system around point O, if you take moment around point O, then 3W x bar should be equal W. 3W x bar should be equal W. I mean, moment 3W x bar should be equal W. W. 3W x bar should be equal W. W will cancel out. Therefore, x bar should be equal R over 3. R over 3. Is that clear? And අර මං කලින් හැදුවේ එකම වචනයක්වත් ලියන්න තු මං හැදුවේ දැන් මේ ඔයගොල්ලන් තේරුම් ගන්න ඕන නිසා මේ ලිව්වේ. හරි. Now tell me if you get this explanation, please raise the hand. තේරුණා question. Okay. Thank you. Now you can write my method පුතේ. මේ මගේ method එක ලියාගෙන කට්ටිය. ටක් ගාලා මගේ method එක ලියන්න. Then I will do explanation. Okay. Write on this. Write my review, Pate. Write my review. Area of a circle is directly proportional to R square. Is directly proportional to square of the radius. Square of the radius. Area of a circle is directly proportional to the square of the radius. The square of the radius. The weight of a lamina, is directly proportional to area. Is directly proportional to area. The weight of a lamina is directly proportional to area. The weight of a lamina is directly proportional to area. Therefore, the right under that. Therefore, weight is directly proportional to the square of the radius. For circles only, make a circle or right. Is square of the radius for circles only. How it is checked in Nispati? Hey. Because this is a lamina. Lamina means it is a thin sheet. No, lamina means thin sheet. That means all the particles are distributed on a plane. Lamina means plane. As I mentioned you earlier, lamina has an area only. It doesn't have thickness. It has no thickness. Lamina means it is a plane only. Therefore, all the particles are distributed on a plane. Plane has a area only. There are three densities. One is linear density. Other one is surface density. The third one is normal. We call it as density, volume. Linear density. Linear density means if the mass is distributed through a linearly, if the mass is distributed through a linear path, that means something like a wire or something, then we can take it as a linear density. Because all the particles are distributed through a line. Then the weight is directly proportional to the length. In such cases, weight is directly proportional to length. මං දුන්නනේ ඒ ටික. There are three densities. මං දුන්නනේ. එල්ලන්න ඕනේ නේද? There are three densities. One is linear density, other one is surface density, other one is volumetric density. But that means normally we call it as density. And so if the particle of the object is distributed on a line, that means it doesn't have a area or volume. It has only a length. Therefore, mass is distributed through a length. So in such cases, density is called linear density. Linear density means mass per unit length. If that means this one, linear density. First one is linear density. So linear density means if the mass is distributed through a line, this kind of object do not have a volume or area. It has a length only. Therefore, we cannot define the density is equal to mass over volume. We cannot define the density is equal to mass over volume for this kind of object. Because this kind of object may do not have volume. Object එකේ volume එකක් නැහැ. Volume එකක් නැත්නම් density කියන එක mass over volume කියලා define කරන්න බෑ. Therefore, if the mass is distributed through a line, we define the density as linear density. Linear density means mass per unit length. Therefore, linear density, normally we call it as lambda. Linear density is mass over length. That means mass per unit length. Mass per unit length. Therefore, if you have this kind of object, the mass depends on length. And therefore mass depends on length. Then the second type of object are called lamina. Lamina means it is a plane. Means it is a thin sheet, like a A4 sheet. It is thin sheet. Lamina, circular lamina, then triangular lamina, any kind of lamina. Lamina means it is a plane. So if it is a plane, it has an area. It has an area. But it has no volume. It has no volume. All the mass is distributed throughout area. Therefore, all the mass are distributed throughout area. It has an area only. Here length only. Therefore, density of lamina is defined as surface density. Surface density is defined as mass per unit area. And So if we have a lamina puthe, density cannot be defined as mass or volume because it doesn't have volume puthe. Make a volume magnet, the volume magnet. This mass is distributed to an area. Therefore, if you want to find the density should be mass over unit area. Mass over unit area, mass over area. The third one is normal object. That means object that has a three-dimensional shape. A three-dimensional shape. 3D object. 3D object. 3D object means normal objects. Therefore, density of 3D object rho is equal mass over volume. Mass over volume. So those are the three densities. Those are the three densities of materials. Those are the three densities of material. මම හිතන්නේ මම මේක නෝට් එකක් විදිහට දුන්නා නේද ගිය පාර. මම ආයෙසරක් කොන්න කියලා දුන්නේ. හරි. මේක අපි නෝට් එකක් විදිහට ලියාගත්තා නේද? හරි. එහෙනම් ලැබුණා එක මෑත්ස් එක හොයන්නේ පුතේ density into area. Density into area. Here density is represented by rho. Rho means sigma. That means surface density. It is surface density. Maybe the unit of this density is kilogram per meter. Unit of this density is kilogram per square meter. Here kilogram per cubic meter. And weight is relative proportional to radius. Therefore, if the weight of the small circle is W, therefore, if the weight of the small circle is W, therefore, if the weight of the small circle is W, the weight of the biggest circle is 4W. Weight of the biggest circle is 4W. Then the weight of the remaining part, then the weight of the remaining part is 3W. Then the weight of the remaining part is 3W. I will repeat it again. If the weight of the small circle is W, then the weight of the biggest circle is 4W. Then the weight of the remaining object is 3W. Then the weight of the remaining object is 3W. Okay. They are writing another para. 4W is the resultant of TW and W. OW is the resultant of 3W and W. Therefore, it should be in the middle of, sorry. Therefore, it should be in between 3W and W. I will repeat it again. The resultant force of 3W and W is 4W. 4W is the resultant force of 3W and W. Therefore, it should be in between 3W and W. Right. That's it. Okay. Now, can you apply this method to solve the second question? Tagga method use the second question. Tagga what is the second question? Okay. Now you can use this method to solve the second question. Please do the second question very quickly. Very quickly. Maybe you have done the second question, but do it again using this method. Tagga. Okay, look at this one. Now you know this part has a radius of r. The biggest part has a radius of 2r. So as I mentioned you earlier, if this part if the weight of this part is w, the weight of the biggest part is 4w. Therefore, this one is w, this one is 4w. Then the remaining part is if the weight of the remaining part is 3w. Therefore, 3w should be located at this position. Ah, sorry. This is not the one. This is the remaining part. Sorry. Actually, there is no remaining part. Again, this one is attached to it. Again, this one is attached. Now, all of you should be shift a little bit to the left right hand side. All of you should be. I don't know whether the location is it should be somewhere. Okay, I will explain. Okay. Well, now look at this one. Now there's a circle here. There's a circle here. There's a circle here. Initially, the 4W should be at this position, at the center. Weight of the circle is 4W. It should be at the center. Is that clear? Make it there now. Initial, this should be at the center. Look at this one. Everyone, please look at the board. Everyone. Initially, there is a circle which has a radius of 2r. Therefore, 4W, initially 4W at the center, that means O. At the center. Is that clear? Is that clear? Make it Pusan. Initially, there's a 2r circle pute. There's a 2r circle, therefore, its weight is 4W. Therefore, it should be at the center. Is that clear? But I'm going to answer it. I'm going to combine some Java. If it is clear, please raise the hand. Now, from that circle, this kind of portion is removed. This kind of portion is removed. This kind of portion is removed. No. Initially 4W, the center of gravity was at center. Now the weight is reduced to TW. The weight is reduced to TW, and it is shifted R/3 towards this side. We found that previously. Therefore, after removing this part, here 3W put it is shifted R/3 to the left hand side. Is that clear? If it is clear, please raise your hand. Make the second part. Methane, maybe. Make the Pusa. Make the Pusa. I need response on video, but I'm only responded to the Purana. What happened? Here, now, then may part remove the. Now this part has removed. And now what will happen? Now there is an object. Now there's an object like this. There's an object like this. It is not a regular object with it. Now there's an object like this. Now its center of gravity is at this position, PW. R/3 position. Now we are going to fix this kind of circle into this. We are going to fix this kind of circle into this. And now the weight of this circle is W. The weight of the circle is W. And now the total weight of the object should be 4W. Now 3W, 4W, but I don't know where it is. Okay? Definitely it cannot be at the center. It cannot be at the center, because if it is at center, then definitely it should be like this. Okay? Therefore, definitely it should not be at the center. And therefore, definitely it should be somewhere into the right hand side of the center, because now the mass is here. Now mass is here. Therefore, the center of gravity might be shifted to right hand side, because this mass is attached to the right hand side. Therefore, the center of gravity might be shifted to right hand side. And therefore, Therefore, now the center of gravity should be somewhere here. So you need to determine the center of gravity position of this. You need to determine the position of this last center of gravity. Is that clear enough? Is that clear enough? If it is clear, please raise the hand. If it is clear, please raise the hand. I need responses from everyone. Yes, Shiv? Now you have the answer. Is it okay, Pute? Therefore, I don't know actual location of this center of gravity. Therefore, I took it as x bar. I took it as x bar. I don't know whether it is it. No? I know this length. This length is R03. This length is R03 from here. Then, if it is x bar, you know the diameter of this circle is 2r. Diameter of this circle is 2r. So, if it is x bar, this part should be 2r minus x bar. 2r minus x bar. And this length should be r because this is the center of the circle. Center of the circle. Therefore, this one is B. You know, OB distance is x bar. Therefore, BC distance should be 2r minus x bar plus r. That means 3r minus x bar. Therefore, now you know BC distance and A, B distance. A, B and BC distance. And now there are two forces, TW and W, around point B. The distance to TW is equal R over 3 plus x bar. Distance to W is equal 2r minus x bar plus r. If it is okay, please raise the hand. I need responses from you. What have Mungim responded then put in a tongue? That is unnecessary. No, you are going to take the momentum on B. You are going to take the momentum on B. B means this position. B means the position of OW. Therefore, there is no moment of OW. The length distance is zero. That's why I take the moment about point B because B means that is the point of resultant force. Therefore, the point, if you take the moment about the resultant force, then the moment of the resultant force is zero. That means the moment of the entire unit should be zero. That means clockwise moment should be equal to the anti-clockwise moment. If you take the moment about the resultant force, definitely the resultant moment should be zero. Therefore, clockwise moment should be equal to the anti-clockwise moments. Clockwise moment should be equal to the anti-clockwise moments. Therefore, there is no moment from 4W because you are taking moment about point B. You are taking moment about point B. That's why I took the moment about point B. Then you can equate the anti-clockwise moment and clockwise moment. Okay? There is an anti-clockwise moment from 3W, clockwise moment from W. Those should be equal. Is that clear? මම කියපේ තේරෙනවා අතුසනේ මම අපි කතා කරා මොමන්ට් එක 0 වෙනවා නම් ඒ කියන්නේ මොකද රිසල්ට් ෆෝස් එක වටේ මොමන්ට්ස් ගත්තොත් එහෙම අනිවාර්යයෙන් මොමන්ට් එක 0 වෙනවා මොමන්ට් එක 0 වෙනවා කියලා කියන්නේ anti clockwise moment should be equal to clockwise moment. So if you get my point, please raise the hand. Clear to something? Then I took the moment about point B. I took the moment about point B to take. Point B means that is the location where the 4W is exerted. Therefore, this is the resultant force. If you take the moment about resultant force, then the moment of resultant force will be zero. That means moment of the entire system should be zero about that point. And moment of the entire system should be zero about that point. Therefore, clockwise moment should be, sorry, anti-clockwise moment should be equal to the clockwise moment. Anti-clockwise moment means 3W into this length. That means R over 3 plus X bar. Clockwise moment is equal to W into this length. That means 3R minus X bar. From that, you can find the value of X bar, that is R over 2. R over 2 means from O to this distance. මේක ඇති ඒකට මම මේක දැම්මේ අර සමහර ළමයි මෙතන D වලින් නම් හොයලා තිබ්බා. එතකොට D වලින් නම් පුතේ ආන්සර් එක 5R over 3. 5R over 3. Is that okay? Okay. If you got my explanation, please raise the hand. I need responses from everyone. පුතේ මට හැමෝගෙම respond එකක් දෙන්න. තේරුම් නැත්නම් කියන්න. හැමෝම අත උස්සන්නේ මම කිය හැමෝම තේරුණා නම් විතර කතා උස්සන්න. Thank you. Steve, Supulma, what happens? Did you get? Thank you. Okay. In that. Shall I erase? Shall I erase? If you want to take a screenshot, you can take. The screenshot I can. Okay. Okay, then do the fourth method. Oh, hello there. Have finished? මොකක්ද මේ කරන්නේ? මෙතන එක්ස්පීරියන්ස් ගන්න ගොඩක් දේවල් තියෙනවා. එක්ස්පීරියන්ස් ගන්න බලන්න දැන් කට්ටිය. What I have done here? මොකද මම මේ කරේ? Okay, okay. බලන්න ගමු. First one. First thing. First thing, you have to determine the sorry. It doesn't matter, Uday. It doesn't matter. Because I have taken the moment about point B, therefore it will not affect. Come on, thank you. Anyway, here again I have one thing you have to know. That means this is a lamina, this is a lamina, therefore area, weight directly proportional to area. But no need to take the area, no need to take the area. Look at this one. So if you consider this dotted line, now this is a square, this is a square. Therefore, this small portion also is square. This small portion also is square. If you consider about this dotted line, so this is a half of a square. This one also half of a square. No? Right? So if you consider this dotted line, this hash portion is a half of a square. And this hash portion also half of a square. Half of a square and half of a square. Okay? This is a half of a square. So this one also half of a square. Therefore, the removed part is equal to one small square. The removed part is equal to one small square. Then the removed part is equal to one small square. The entire part has 4 such squares. The entire part has 4 such squares. Then removed part is equal to 1 square. Therefore, if the weight of the removed part is W, the entire weight should be 4W. Is it okay? If you got my explanation, please raise the hand. තේරුණා නේද උසන් එක? මම මේ W 4W කියලා ගත්ත එක තේරුණා නේද උසන්? Thank you. Then the weight of the small portion is W, entire portion is 4W puthe. Therefore, if I remove that part, the rest of the thing is equal 3W. My first attempt is finding the center of gravity of rest of the things. And because this portion means removed portion is attached to the remaining portion. Therefore, you need to determine the center of gravity of the remaining part first. Otherwise, there will be 2 unknown factors. One is I don't know this distance. I don't know this distance. And I don't know this distance also. Therefore, there are 2 unknown factors. Therefore, you cannot solve the question. The first thing you have to determine what would be the center of gravity of the remaining part after removing this portion. Therefore, I have done the exact same thing which was done earlier. So this is W, this one is 3W, then remaining part. So if I combine these two, if I combine this kind of portion, this black color one, with this color one, red color one. If I combine this black color one and red color one, you will have the entire square, the whole square. The center of gravity of the entire square is at the point O. I know that thing. I don't know where the TW is. That is my objective, finding the location of TW. And I know this one. You know the center of gravity of a triangle. The center of gravity of the triangle is at the centroid. Centroid is at the centroid. It can be determined using 2 to 1. 2 to 1 ratio. 2 to 1 ratio of any median, Putin, of any median. Therefore, you can take, if you know a median means bisector to the adjacent side. Bisector to the adjacent side. So, if you consider about a median, the centroid is located 2 to 1 ratio, 2 to 1 ratio from this vertex. Therefore, this position should be, you know, the entire length is 3R. Entire length is 3R. Therefore, from here to here 2R, from here to here R. Is that clear? Centroid division. Centroid division 2 to 1 ratio. So you have to first draw the median. You know this one is a median because this is a square. As this is a square, it is very clear this part should be equal to this part. That means this is a bisector to this side. This is a bisector to this side. Therefore, if I consider about OD line, OD is a median. Therefore, the center of gravity of this triangle, should be located 2 to 1 ratio from this vertex on the median. 2 to 1 ratio. 2 to 1 ratio. 2 to 1 ratio means altogether 3. No? 2 to 1 ratio means altogether 3. Therefore, now it is very easy to determine because you are given this length is 3R. As this length is 3R, from here to here, it should be 2R. From here to here, it should be R. Is it clear? If it is clear, please raise the hand. Triangle. If it is clear, please raise the hand. If you need further explanation, I will give you the. Right. Then tell me, if you want to explain this one again, please let me know. OA. I'm explaining. Now I am explaining that part. Now I am explaining that part. You see, like now I am explaining that part. Please listen to me very carefully. Listen to me very carefully. Purpose I may actually, this one is the location of 3W. Location of 3W means after removing this one. Therefore, you have to find that one. So this is the procedure of finding that one. Please listen to me very carefully. Uday. Look at this one. So this is the initial shape. If you remove triangle shape from the initial shape, then this is the location of 3W. The location of center of gravity. I don't know this length. Now I'm going to find that one. And then this is 3W, this one is W, the remove part. Then remove part, is located 2r from O. 2r from O. 2r from O. How did I find that one? Because this is a triangle. This is a triangle. And you know OD is a median of the triangle. The center of gravity of a triangular lamina is located at the centroid. That means 2:1 ratio from the vertex on a median. So OD is a median. Therefore, from here to here length should be 2r. Here to here length should be r. Here to here length should be r. Because you know from here to here length is 3r. 3r is given. 3r is given. Therefore, this length should be 2r. This length should be r. Right. Then you know from this from O, this length is 2r. This length is x bar. Then if you take the moment about point O, this is the resultant force, then the anticlockwise moment should be equal to the clockwise moment. Today, anticlockwise moment is equal 3w into x bar is equal w into 2r. Therefore, x bar is equal to 2r over 3. X bar is equal to 2r over 3. Therefore, OA distance is equal to r over 3. This is same. This one is same. Did you get my point? If you get my point, please raise the hand. Please give me your response. Okay, I will. Rashid, මොකද අත්තේ? සුපර්ම මොකද අත්තේ? Please listen to me very carefully. First one, please listen to me very carefully because I am explaining all the thing. Okay, hold on. Okay, look at this one. Look at this one. So this is the initial image. This is the initial image. No, initially, there is this kind of square. There was this kind of square. Is that clear? Now, this kind of portion is removed. This kind of portion is removed from the square, and again it is attached to this part. And therefore, it is very clear this part is 3w, this part is 4w and w there. But to determine x bar, you have to know this value. Otherwise, this value also unknown factor. If this value is unknown factor, then you cannot do this. This value means the length, the actual location of 3w. You have to determine the actual location of 3w. And actually, now you are going to make an objective. Now you are going to determine the actual location of 4w. Now you are going to determine the actual location of 4w. So this would be the unknown factor. If you want to determine 4w, all the other things should be known. All the other should be known. Therefore, you have to know the exact location of w. You have to know exact location of 3w. And therefore, the first thing you have to do is you have to determine the exact location of 3w. 3w means now this is the procedure. Look at this one. Now there is a square. There's a square like this. You are going to cut this square from here to here. Now this part is removed. So after removing this part, your object is like this. Your object is like this. Now you are going to fix the removed part to this object. So remove part this object. Now, once you remove this part, the weight of the object is 3W. How did I get that one? It is very clear. The weight corresponding to area. Balanga, if you look into this hash portion, this is actually this is square. The entire square can be divided into 4 segments. This is a square. This one also is square. This one also is square. This one also is square. So a hash portion means half of the square. This hash portion is half of the square. Altogether, this is a 1 square. This is 1 square. There are 4 squares in this entire image. The entire image, there are 4 squares. And there are 4 squares, but 1 square is removed. 1 square is removed. Therefore, if I take the weight of the removed one is W, if the weight of the removed one is W, the weight of the entire part should be 4W. Is it okay? ඒක තේරුණා නතුසන් මේ රිමූව් කරපු එක W නම් entire part එක 4W කියලා තේරුණා නතුසන් මම ඩක්කා රෙස්පොන්ඩ් කරන්න පුතේ මේක නැත්තම් පරක්කු වෙනවා නැත්තම් මම අර එකම එක කී කියා ඉන්නවා ඒක හරි බලන්න එහෙමනම් look at this one. Therefore, the entire part is W, sorry, entire part is 4W, remove part is W. Therefore, if you remove this part, the remaining part, the weight of the remaining part, is 3W. Therefore, this weight is 3W. Okay. All right. Now, you have to take the actual location of this one. Actual location of this. Suppose this one is මම මෙතන x bar කියලා ගන්න මම මෙතන ගන්න මොකක්ද ගන්න y bar කියලා for instance මම x bar කියලා දැක් ගන්න තියෙන සයිඩ් පැටලෙන්න පුළුවන්. So you need to determine this y bar first. You need to determine this y bar first. So how to determine this y bar? So this is very easy. This is exactly same way which I have done earlier. Okay. So this is the remaining part today. So if you attach the remove part, to the remaining part, you will have the previous one. Therefore, this black color one is the remove part. This red color one, this black color one is the remaining part. The black color hatch one is the remaining part. This red color hatch one is the remove part. If you combine the remaining part and the remove part, you will have the full object. Is that clear? If it is clear, please raise the hand negative now. Yes, that's why I may say. මෙතන මම කරේ මේ remove part එක combine කරා. හරි. combine කරලා පස්සේ full image එක එනවා. හරි. Then definitely the weight of the remaining part is W පුතේ. Weight of the remaining remove part is weight of the remaining part is W. Remaining part is 3W. If you combine that two, you will have the first image. That means full circle, full square. Therefore, 4W should be exerted at the x-axis center. හරි. මේ දෙන්නගේ weight එක මේ දෙන්නගේ resultant එක තියෙන 4W පුතේ අනිවාර්ය x accent එකේ තියෙනවා. ඒක තේරෙනවද? මොකද combine කරලා පස්සේ full square එක හම්බ වෙනවනේ පුතේ. මේක combine කරලා පස්සේ full square එක හම්බ වෙනවා. full square එකේ weight එක තියෙන්න ඕනේ කෙලින්ම x accent එකේ. ඒක 4W වෙන්න ඕනේ. හරි. ඒක තේරුණා නතුසන්. if it is real please raise the hand. තේරුණා නතුසන්. Then you need to determine this distance today. I don't know that distance, but now you know this distance because now this is a triangle. You have removed triangle part. You have removed triangle part. Then how to get the center of gravity of triangle part? It is centroid. Centroid means you have to consider a median. Median should be divided into 2:1 ratio. 2:1 ratio. This is a median okay? This one is a median. Median should be divided. Median should be divided into 2:1 ratio. 2:1 ratio to get the centroid. Now you know the entire length is 3r. It is very easy. The entire length is 3r. That means from here to here 3r. Therefore, this length should be 2r. This one is r. 2r, 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 2r. Therefore, from here to here, distance is 2r. 2r. If it is okay, please raise the hand. Negative no to sir. 2r gate no to sir. I need responses. I need responses. Then you can determine y bar. How to determine y bar? You can take moment about point A. Point or take moment A. 3W into y bar should be equal to r into w. Therefore, y bar is equal to 2r over 3. Y bar means that is the place of remaining, that is the place of the center of gravity. That is the place of the center of gravity of remaining part. Remaining part. From point O. That means OA distance. And then you can take that information to here. Now there is a remaining part. This one is remaining part. This one is remaining part. Okay. That's remaining part here. That's remaining part here. Now you know the center of gravity of the remaining part, that is 3W put there. Now you know the center of gravity of remaining part, that is 2r over 3 distance from the center. 2r over 3 distance from the center. That is, this length is 2r over 3 distance from the center. Now you have attached the cut one like this. You have attached the cut one like this. And if you attach the cut one like this, you know the center of gravity of cut one. This part. Is it W? Is it W? This length should be R. This length should be R. Triangle and method 2R, method RT. And now you don't know. Now the weight of the entire object. The weight of the entire object is 4R again. 4R again. But you know this part is removed and again it is attached to the object into the other side. Therefore, I don't know where the 4W is. Then I mark it like this. Then take the distance is x bar. So if this length is x bar, my length is x bar, this part should be 3r minus x bar. This part should be 3r minus x bar, and this part is r. This part is r. And therefore, now you know the distances. A to B distance is 2r over 3 plus x bar. B to C distance is 3r minus x bar plus r. If it is clear, please raise that. Now, these two forces are the two forces. This is the result force. You have to take the moment to the system around this point. Then 3W into this distance equal W into this distance. Then you can take the exponent. Then you can take the exponent. If it is okay, or if you got my explanation, please raise the hand. If you got my explanation, please raise the hand. තේරුණා තුස්සට. Okay, thank you. Thank you, පුතේ. හරි මේක දාගන්න. Okay. You can write this one and take a small break, Pute. Take a small break. Now 8:30. Please come back at 9 o'clock. Please come back at 9 o'clock. We'll start the rest of center of gravity. ගොඩක් වෙලා ගියා මේක explain කරන්න. ගොඩක් වෙලා ගියා explain කරන්න. හොඳට මම ආයෙත් කියන්නේ. ඊළඟ lesson එකට යනකොට ටට්ටක් ගාලා answer දෙන්න ටට්ටක් ගාලා lesson එකේ ඉන්න. lesson එකේ ඉන්න කියලා කියන්නේ පුළුවන් තරම් තේරුම් නැත්නම් තේරුම් නැහැ කියලා කියන්නේ තේරුණා නම් තේරුණා කියලා කියන්නේ respond කරන්න. මට ඒක ගොඩක් වටිනා පාඩම වේගෙන් ගෙනියන්න. Okay, after the break, I will give a note. Okay. You can prepare a note if you understood. You can prepare a note. And so within the break, can you prepare a note? Then send that to me. Then I will check whether there is a mistake or not. That is very good. And ඒක හොඳ කතාවද. හරි. break එකේදී ඔයගොල්ලෝ මේකේ review එක ලියලා මට එවන්න. හරි. නෑ. හැමෝම හරි මේකේ review එක ලියන්න මොකද්ද කරේ කියලා. මේක essay එකක් වගේ ලියන්න එපා. essay එකක් වගේ ලියන්න එපා. essay එකක් වගේ ලියන්න ඕනේ. නිකන් මොකද්ද උනේ කියලා. හරි. ලියලා මට එවන්න මම බලන්න. 12 o'clock. Okay, take a break, Pute. Nine, 10. Okay, shall we start there? Okay, if you're in the class, please may give me a thumb. Happy, gonna come with that. Okay. Okay, now you can start with it. Hi, I will give a note on this. So write this review regarding this discussion. Try this one, okay? Oh, maybe P Q R S T. P Q R S T. I have marked this vertices as P Q R S T. Then try this one. Here, ROQ triangle is removed from the square. Here, ROQ triangle is removed from the square. Therefore, therefore, the center of gravity of the remaining part, the center of gravity of the remaining part, the center of gravity of the remaining part should be determined first. Then, then, then the removed part is attached to the remaining object. Then the removed part is attached to the remaining object. Therefore, therefore, the center of gravity of the combined object. The center of gravity of the combined object can be determined using principle of moment. Principle of moment. Okay. Now we are going to look into the shifting of center of gravity from the original location. So, according to our explanation, center of gravity means that is the location where the weight is exerted on the object within. That means actually that place is the place where the weight is exerted on the object. And suppose if suppose now this is a circle. Initially, the center of gravity should be at the center of this circle. Now I have removed some part from the circle. If you remove some part, then here there's no mass here. There's no mass here. Therefore, mass is actually mass is now the mass is distributed into this side today. This side means actually now there's no mass. Here there's no mass. Therefore, mass concentration is highly around this area. Here there's no mass area. Therefore, now mass is on this area only. Therefore, in such cases, the center of gravity should be shifted to the left hand side to the left hand side. Make a left hand side till shifted node. And because now the mass is concentrated to this one. Initially, mass is evenly distributed today. Mass is evenly distributed, therefore, the center of gravity is located at the center. Now in this side, actually we can consider in this side, there's less mass. In this side, there's less mass than here. Therefore, most of the mass is concentrated at this area. Therefore, the center of gravity, because normally the center of gravity is shifted to the mass concentrated area. Therefore, the center of gravity will be shifted to the left hand side. The same scenario can be done using this. Now, initially, this object is a symmetrical object and the center of gravity should be at the center. Now I have attached an additional mass into this area, into this location. Here, mass is removed, now additional mass is attached. Therefore, if we consider about these two portions, the weight of this portion is less, the weight of this portion is high. Therefore, the center of gravity will be shifted to the more weight area. That means the center of gravity should be shifted to the highest mass concentration location. Therefore, in here, there's a where the weight is higher in this area than this. Therefore, center of gravity will be shifted towards the right hand side. The center of gravity will be shifted towards the left hand side, here towards the right hand side, because mass concentration is high in right hand side here. Here, mass concentration is high in left hand side. And therefore, center of gravity is located in high mass concentrated area. Is that clear? How the shift here? Mass concentration very pattern shift. Is that clear? Diligan atusan. Okay. Now you can draw this one. Okay. Write this one under it. Write this one up. Write all this. Write all this. Usually, the center of gravity is shifted. Usually, the center of gravity is shifted towards a location. Okay, I will repeat it again. Usually, I will repeat it again. Usually, the center of gravity is located. Usually, the center of gravity is located at a place. Usually, the center of gravity is located at a place where the mass concentration is high. Where the mass concentration is high. Then the next one. Next topic is put types of equilibrium. Okay. Okay, look at this one. Now, look at this pen. Now this pen is on my hand. Now this pen is on my hand. So if it is on my hand, actually, now this pen is on the book. And so is this pen in an equilibrium condition? Whether the pen is in equilibrium condition or not. Now this pen is in equilibrium condition or not. I need answer from everyone. Now this pen is on the book. My question is, my question is whether the pen is in equilibrium condition or not. මේ pen එක මෙහෙම තියෙනකොට මෙයා equilibrium condition එකද නැද්ද ඉන්නේ? Yes, it is in equilibrium condition. Yes, it is in equilibrium condition because its current state remains unchanged. Therefore, it is in equilibrium condition. But can I move here and there with this pen? No, right? Because from very little movement, this equilibrium condition can be damaged, no? And the damage means it can be removed. Actually, even though this pen is in equilibrium condition, actually, if I move here and there, that condition is this pen can be fall. And that means that condition can be changed. That condition can be changed. And therefore, such kind of equilibriums are called as unstable equilibrium. Although the object is in equilibrium condition, by very little displacement, that equilibrium condition can be changed. That means the object can be moved. And such kind of equilibrium conditions are called unstable equilibrium condition. Unstable equilibrium condition means actually that equilibrium can be removed. That equilibrium condition can be removed today. And look at this one. Now what will happen? Actually, this condition is much more stable. This condition is much more stable than the previous one. This condition is much more stable than the previous one. And therefore, according to the actually, according to this explanation, it is very clear there may be some special types of equilibrium, because some equilibrium are not stable. Although the object is in equilibrium condition, with a very little movement, that condition can be damaged. The object can be moved. But some equilibriums are very, very stable. Very, very stable. Stable one means actually we cannot change this. We cannot change the current position easily. And therefore, according to the way of equilibrium, there are three types. There are three different types in equilibrium. Three different types. The first one is stable equilibrium. Stable equilibrium means it is something like this. Suppose now this is some kind of hemisphere. This is a hollow hemisphere. Okay. Now there is a ball inside this one. So if I move this ball up to some extent, then what will happen? If I move this ball and release it, then what will happen? After releasing, this ball will oscillate several times. This ball will oscillate several times and come back to the original position again. Is that clear? Initially, the object was at this position. Although I have moved this object a little bit and release it, what will happen? This object will oscillate. This object will oscillate several times, and after a while, this object will come to the initial position after a while. Is that clear? මොකද වෙන්නේ කියන මේක පොඩ්ඩක් ගහක් කරොත් මොකද වෙන්නේ? ඕක ඔස්කිලේට් වෙලා ටික වෙලාවක් ඔස්කිලේට් එක ගිහිල්ලා මොකද වෙන්නේ? ඒක අඩු වෙලා ගිහිල්ලා ආයෙසර පයින් තැනට වෙනවා. If it is clear, please raise the hand. තේරෙනවද උස්සන්නේ? Today, this kind of equilibriums are called stable equilibrium. Stable equilibrium means, although if we give a small displacement to the object, this object will come to the initial position and come to the equilibrium again. Although we have displaced the object a little bit, that is stable, that equilibrium will not be removed there. what will happen? This object will come to the original position and come back to the equilibrium condition again. Alright. Therefore, this kind of equilibrium is called stable equilibrium. Stable equilibrium to the stable equilibrium. And therefore, in stable equilibrium, there's a characteristic with it. Characteristic means this equilibrium location, that means position of the equilibrium will not be changed. That means if I change the position of the object, it will come back to the original location and come back to the equilibrium condition too. And make a original location equilibrium condition. So that is the characteristic of stable equilibrium. And suppose this kind of object is here. You know, there are the mass, if you consider about this kind of object, the mass is concentrated into the bottom. Therefore, most of the case, their center of gravity should be located very close to the bottom, because the mass at the bottom is relatively high. Right? Then, suppose if you give a small displacement to this object, then what will happen? Then this object will move like this. So if I give a little displacement to this object, then what will happen? This object will move like this. So you know, this is the center of gravity. This center of gravity. Therefore, although if I may move into this side, now from this center of gravity, again it will come back to the original position. I may protect this. As the center of gravity is at the lower height, means as the center of gravity is at the bottom of the object, what will happen? Although if I move this object into this side, although I move this object in this side, there will be a moment to the other side. There will be a moment to the other side by this way. Okay? There will be a moment to the other side by this way. So during this reason, again this object come back to the original position. මේ වගේ එකක් අපි move කරලා බලමුද මෙහෙම කරලා තියලා තර එකක් මොකද වෙන්නේ? සෙලප් බීමට පරිදි වෙන්නේ. මේ වගේ එකක්. ඔයත් මේවා තියලා මේක මෙහෙම කරලා අතර එකක් මොකද? සෙලප් පළවෙනි තැනට වෙනවා. If I move this object a little bit and remove, then it will come back to the original position. It will come back to the original position. Therefore, if I give a little displacement to this object and release, it will come back to the original position. Therefore, such kind of equilibrium is called stable equilibrium. Therefore, stable equilibrium, the characteristic is the object, although if I give a little bit displacement to the object, it will come to the equilibrium at the initial position. It will come back to the initial position and again it will come back to the equilibrium condition. Write this one. Draw this one. Hello there. That's the equilibrium. First one is stable. First one is stable. You have to write the topic also. First equilibrium is stable equilibrium. Stable equilibrium. Look at that. Stable equilibrium. Don't write this one. Just draw this. Okay. Try to do this. If a small displacement is given to the object, if a small displacement is given to the object, it will come back to the original position and come back to the equilibrium condition again. It will come back to the original position and come back to the equilibrium condition again. Such kind of equilibrium is called a stable equilibrium. Such kind of equilibrium is called a stable equilibrium. Okay. What was my last sentence? Antima sentence. Makan antima sentence itu. Nah, pada complete kali lah, such kind of condition is called stable equilibrium condition. Okay. Therefore, the most important thing is this will come back to the original position and again come back to the equilibrium condition. But to have such kind of equilibrium, the center of gravity should be located at the lowermost position. That means lowermost position is at the lower position, at a lower position, not the lowermost position, but at a lower position. And the center of gravity should be located at a lower position. Something like this. The weight should be located at a lower position. Therefore, if I give a small displacement due to this force, it will create the opposite movement for the moment. So if I give a move as the weight is at a lower position, now what will happen? Now I want to move this object here, but this way creates a moment to this direction, Therefore, due to the way, there's a moment towards this direction, which anti-clockwise direction. And with may weight taking moment anti-clockwise direction. Therefore, again, this object come back to the original position. This object come back to the original position due to this anti-clockwise moment. And therefore, if the weight is at a lower position, what will happen? It will come back to the original position when, even though there is a very little displacement. Even though a displacement is given to the object, it will come back to the original position due to its weight. If it is clear, please raise the hand. Can you understand this? Can you understand this? No, I am discussing about stable condition. Stable condition. Please listen to me very carefully, Buddha. Please listen to me very carefully. I am discussing about stable condition. I just want the topic, Buddha, but listen to me very carefully. But I'm hanging and please listen to me very carefully. Hmm. Actually, I have described the scenario of this condition today. Actually, what is the scenario of this condition? If I rotate, if I try to rotate this object, or if I give a small displacement to this object and release paper, what displacement what will happen? Now this object is a display. This object touch the ground at this position. Now this object touch the ground at this position. Now the center of gravity is at this position. That means it is a very low position. Therefore, if I take the moment about this point, for this object, definitely there will be a moment towards this direction. Moment again. So due to this moment, what will happen? This object will rotate. Means it will rotate into the initial position. May moment initial position. That is the reason. That is the reason. Therefore, if there's a stable condition, if there's a stable equilibrium condition, there's a mandatory requirement, that is the center of gravity should be located at a lower position. The center of gravity should be located at a lower position. And that is a mandatory requirement. Otherwise, it will be toppled. And මේක මේ වගේ උඩ වගේ ගියොත් එහෙම මොකද වෙන්නේ? මේ අනිත් පැත්තට පෙන්නේ. මේ වුණත් මේක අනිත් පැත්තට පෙන්නේ. ඒක නිසා center of gravity එක අනිවාර්යෙන් පල්ලෙහා තියෙනවා. Is that clear? තේරුණාද? Is that clear? Thank you. Okay. Therefore, try this one. Therefore, in this kind of condition, Pute, center of gravity located at a low position. You know, as the center of gravity is located at a low position, then the height from the earth to the center of gravity is a lesser value. Therefore, the potential energy of this object is a lower value. Potential energy means mgh. Mgh means that is the height to the center of gravity. Therefore, potential energy of this object is a lower value because the center of gravity is very close to the earth. Therefore, potential energy is a lower value. Okay. If you get this thing, please raise the hand. Therefore, if it is a stable condition, definitely center of gravity should be located at a lower condition, and due to this reason, potential energy will be a lower value. And if you get this thing, please raise the hand. I need responses from everyone. Okay, there are this one. Make up that. Okay. Then second scenario is unstable condition, unstable equilibrium. The second scenario is unstable equilibrium. Unstable equilibrium. So it is somewhat clear. This. Oh, we got it better. So, in unstable condition, if I give a very little displacement, and release it, what will happen? This object will lose the equilibrium condition. Then it will move to the another position. And if I give a very little displacement to this and release it, what will happen? This equilibrium will be lost and the object will not come to the original position. Sometimes it may be not in the equilibrium condition. And equilibrium condition and therefore, if there is an unstable condition, if I give a very little displacement to the object and remove it, the object will lose the equilibrium condition and it will not come to the original position. And මේක පොඩ්ඩක් අපුගම්පද ගිහිල්ලා කඩාගෙන යනවා. ආයෙ ඉන්නේ. හරි. ඒ වගේ තමයි. මේකත් දැන් අතොත් යන්නේ. හරි දැන්. So if I go a little displacement here, what will happen? You know, as the mass is distributed to the upper direction, now here mass is distributed or mass is concentrated. No? The mass is concentrated at the upper. Therefore, most of the mass is concentrated at the top condition. Therefore, normally the center of gravity should be shifted to the somewhat higher location. Therefore, therefore center of gravity may be at this kind of position. So, if I give a little displacement to this kind of object, what will happen around point O? So if I take moment to this object about point O, what will happen? This weight creates a moment towards the direction of displacement. That means if I give a little very little displacement to this direction, due to its weight, it creates a moment to the same direction. A moment to the same direction. ඒ කියන්නේ මම මේ පැත්තට චූටි displacement එකක් දුන්නොත් පුතේ මේ weight එකෙන් ඒ පැත්තටම moment එකකුත් හදනවා. Then what will happen? This will not come to the original position. It will topple. It will topple. Therefore, then it will not come to the original position. Is that clear? If it is clear, please raise the hand. තියෙනවා තුස්සන්න. මේක තේරෙනවා තුස්සන්න. එහෙනම් unstable condition එක කියන්නේ මොකක්ද පුතේ? Unstable condition එක කියන්නේ ඒකත් equilibrium condition එක තමයි. නමුත් චූටි displacement එකක් දීපු ගමන් equilibrium condition එක නැති වෙනවා. හරි. චූටි displacement එකක් දීපු ගමන් equilibrium condition එක loss වෙන්න පුළුවන්. හරි. Then draw this one. This is unstable condition. Okay. There I can do this. May I learn? There I can do this. If a small displacement is given, if a small displacement is given, if the small displacement is given, to an object, which is in an equilibrium condition. To an object which is in an equilibrium condition. If a small displacement is given to an object which is in an equilibrium condition. It will lose its equilibrium condition. It will lose its equilibrium condition. It will lose its equilibrium condition and moves towards the direction of displacement. Towards the direction of displacement. ये displacement के दीप पर तरफ ना move. Towards the direction of displacement. Therefore, the object will not come back to the original position. Therefore, the object will not come back to the original position. For this scenario, the center of gravity should be located at a high position, high position. And then this kind of scenario can be happen. The center of gravity should be in a higher position. Right? Potential energy is relatively high. Okay, we got that. Shall I erase this? Okay. There are the next topic is third one. Neutral equilibrium. But the neutral equilibrium is stable like difference on the theorem. Look at this one. Now suppose this guy. This is on. Now this cone is on the floor. So if you keep on like this, and if you rotate this one, then rotate for what will happen? It will rotate and come back, come to another location, and again come back to the equilibrium condition. Therefore, if you rotate means if you give a small displacement, to this kind of object, it will move a little bit. And come back to a equilibrium condition at that particular point, location. And it is something like this. Now there's a ball. So there's a friction here. Now I need to give a force on this board. Force means actually now I'm going to give a very little displacement. Now I'm going to give a very little displacement to this ball. And if I give a very little displacement to this ball, then what will happen? Hmm? If I give a little displacement, what will happen? Okay, then it will come a little bit towards this direction, then again come back to the stable equilibrium condition, and again it will come back to the stable equilibrium condition. And therefore, in both cases, okay, this one and this one, if I give a little displacement to this object, its initial position was changed with it. But its initial position is changed, but it will come to the equilibrium condition again at another position. It will come to the equilibrium condition. It will come back to the equilibrium condition again at a different location. Different location means different position. Therefore, in this case, the this object can come to the equilibrium condition at any position. At any position. Is that clear? මේ කෝන් එකක් තියෙනවා. කෝන් එක පෙරලන්න පෙරලන්න කොතන නවතින්නේ ආද ස්ටේබල් වෙනවා. පෙරලන්න කොතන නවතින්නේ ස්ටේබල් වෙනවා. Is that clear? ඒක තේරෙනවද ඔෆ්සන්? If it is clear, please raise the hand. Now you can do this one. Hi. Then after this, if a displacement, if a small displacement, if a small displacement is given to an object, if a small displacement is given to an object, the object will change its current position. The object will change its current position but 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 is still it can be B in an equilibrium condition at any position. It can be B in an equilibrium condition at any position. You can move කොහෙට සල්ලු කරත් පුතේ සල්ලු කරලා නවතින නවතින equilibrium එකේ. සල්ලු කරලා නවතින equilibrium එකේ. සල්ලු කරලා නවතින equilibrium. හරි. ඒ නිසා අර කලින් අපි ගාවට වෙන්න ඕන කියන නිතියක් නැහැ. හරි. මොකක්ද? Set of gradient. So in neural equilibrium, the center of gravity will not be changed. Center of gravity will not be changed. It is a constant. ඒක වෙනස් වෙන්නේ center of gravity තියෙන location එක. Right. Center of gravity will not be changed. There is a constant. So as it is a constant, potential energy also constant. Because potential energy is equal to mgh. Mgh means you have to measure the h here. And so that cannot be done. Therefore, that h means actually you have to measure this h here. Actually, that h is a constant. Constant. And therefore, potential energy. The potential energy also a constant. The center of gravity will not be changed. The position of the center of gravity is equal. The only thing, this object moves a little bit from the initial position and come back to the equilibrium at a different location. ඒ කියන්නේ මේ වගේ object එකකට ඕනම location එක equilibrium condition එකට එන්න පුළුවන්. හරි? So there is a difference between stable and neutral point පුතේ. So in stable condition, it will come to the original position and come back to the equilibrium condition. In neutral condition, it will not come back to the original position, but it will come back to the equilibrium condition at a different location. Is that clear? Did you get this difference? Did you get the difference? If you get that thing, please raise the hand. The stable condition न्यूट्रल कंडीशन है आता है से मिला तो सर थैंक यू ओके हाँ so बताइए मैं what was my last sentence what was my last sentence मगर वो लास्ट है हम मेरे दूर लास्ट सेंटेंस है दूर yeah they write on that write on that that means the object will come back to the equilibrium condition. The object will come back to the equilibrium condition. That means the object will come back to the equilibrium condition at another different location. At another different location. At another different location. Okay, now try this one. So if it is a neutral equilibrium condition put A, if you give a little displacement to that object, what will happen is center of gravity will not be changed with it. It is same. And the other thing is potential difference, so potential energy. Potential energy also a constant because this height is a constant. Therefore, potential energy also a constant. Look at that. Alright. Shall I raise this one? Okay. Then write a topic for the next topic. Next topic. Types of equilibrium. Types of equilibrium. Relative to a pivot point. Relative to a pivot point. Type of equilibrium relative to a pivot point. Now there are three type of equilibrium. One is stable. Other one is unstable. Other one is neutral. So if it is a stable condition, the object come back to the original position. The object come back to the original position and come back to the equilibrium condition. Okay. Come back to the original position. That is one characteristic. Other characteristic is come back to the equilibrium condition. In unstable condition, what will happen? It will lose the equilibrium condition. It will lose the equilibrium condition. Will not come back to the original position. It will not come back. Will not come back to the original position. Then neutral point puthe, it will stay at the equilibrium condition. Equilibrium condition එක තියෙනවා නේ. Will stay at the equilibrium condition. But different position. Different position. Different position. So those are the characteristics of three equilibrium condition. Those are the characteristics of three equilibrium condition. Hi. You can write this table very quickly. Table. Do it very quickly. Have Have finished? Have finished writing? Okay. Thank you. Okay. Katya balage. मैं आंती है बोर्ड बोलो. Okay. So what is our topic? Pute, what is our topic? Now we have to determine the type of equilibrium with respect to a pivot point. Pivot point means like this. Suppose now this is some kind of sheet or some kind of paper, and you have to fix this paper using a nail. Make a nail like put a fix now you can fix the nail at this position. And pivoting means actually although we have fixed that one, this object can move. This move means this object can rotate with it. And pivoting means although we fix the object, this object can rotate. This object can rotate. This object can rotate. Therefore, pivoting means like this. Therefore, if I fix this object like this, what will happen? Now I pivot this object at this position. Man that pivot karna main position nahi. Look at this. So if I give a small displacement and release it, what will happen? What will happen? It will come back to the original position. No, it will come back to the original position. Okay. It will rotate and come back to the original position. So if I pivot this object, at this position, look at this. If I go a small displacement and release it, then object come back to the original position. Then what kind of equilibrium condition is it? Yes, it is a stable condition. It is a stable condition. No, if I release it, it will come back to the original position. Now we can analyze how did it happen. Put it. Look at this one. Now this is the pivot point. Suppose the center of gravity is lower than the pivot point. Suppose the center of gravity is lower than the pivot point. Suppose the center of gravity is lower than the pivot point. Center of gravity is lower or below the pivot point. Center of gravity is below the pivot point. P means pivot point. So if I do a small displacement, like this, now this is the pivot point today. Now I have given a displacement to this direction. Now may pattal displacement this is the displacement. So this is the pivot point. So therefore, if there is a rotation, that rotation should be occurred around this point, around the pivot point. When the pivot point rotated. Therefore, if there is a rotation, it should be around pivot point. And now, center of gravity is below the pivot point. Then what will happen? Now it is very clear. If you take moment about pivot point, the weight of the object creates a moment opposite to this displacement. But if you take moments about P, this weight creates an opposite moment to the displacement. මේ පැත්ත displace කරාට වැඩක් නැහැ. මෙයා opposite moment එක create කරලා තියෙනවා. Therefore, if you release, once you release the displacement, due to this moment, the object will come back to the original position. Is that clear? If it is clear, please raise the hand. I need responses from everyone. If you need any further explanation, please let me know. Thank you. Therefore, if we consider about a pivot point, okay, then the object will remains as a stable condition if the pivot point is above the center of gravity. In other words, center of gravity should be lower than the pivot point. If so, the object will stay as a stable equilibrium condition. Now look at this one. Now here my sheet put in. Now I am going to pivot. This object at this position. Pivot now I'm going to pivot the object at this position. Then what will happen? So if I do a small displacement, then what will happen? This object will never come to the original position, no? The object was at this position initially. I have pivoted at this point, at this point, Puti. And you know this point is below than the center of gravity, Puti. So if I give a small displacement into this object, what will happen? It will move to the displacement direction of displacement, and it will never come back to the original position. Therefore, what kind of equilibrium condition is this? What kind of thing? What kind of stable condition? It is a stable condition at the end. Body displacement at no, not neutral. It is unstable. Neutral na ඕන තරක ඉන්න පුළුවන් පුතේ. ඕන තරක ඉන්න පුළුවන්. මේක ඕන තරක ඉන්න බෑ. Neutral na ඕන තරක ඉන්න පුළුවන්. This is unstable condition. Because it will never come back to the original position. And it cannot be at equilibrium condition at any point. It cannot be in equilibrium condition at any point. Yeah, its final position can be at a stable condition. That's correct, Putin. Yes, Dina, you are correct. Once we give a displacement to a unstable condition object, it will lose its stable condition. Sorry, equilibrium condition. But after some time, it will come back to a equilibrium condition at another location. That is correct. But unstable condition is like this. Unstable condition is like this. If you give a small displacement, this object will lose its stable equilibrium condition. And this object will lose its equilibrium condition. So due to the loss of equilibrium condition, it will move to another location. So after some time, it can be in equilibrium condition in another location. But first, it will lose its equilibrium condition. And the difference between unstable and neutral condition is like this. Look at this one. Now I am going to pivot this object at this position. When the method minimum pivot kar lo. But so if I do a small displacement, now this object is in equilibrium condition in this position, at this position. If I give a small displacement to this object, again it will be in equilibrium condition at this condition. If I give a small displacement to this object, again it will be in equilibrium condition at this position too. Is it clear? Therefore, neutral condition is like this. Neutral condition, I can change the position of the object. I can change the position of the object. Although the position is changed, the object is in equilibrium condition at any point. At any point. Equilibrium, 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 equilibrium. Is it clear? That is the difference between unstable condition and neutral condition. Unstable condition and neutral condition. So if it is unstable condition, if I give a small displacement, what will happen? First, it will lose its equilibrium. It will lose its equilibrium and change the position. So after changing the position, it can be in the equilibrium condition. And but it is there's a 50-50 chance about it. Sometimes it can be in equilibrium condition. Here it was in equilibrium condition. Sometimes equilibrium condition will be lost permanently. And හිතන්නකො නිකන් අර මේ මොකක් කරේ අර මේක තිබ්බා කියලා ලොකු මේ ස්ලෝප් එකක වගේ මොකක් කරේ දෙක කන්දක් පුළ වගේ මොකක් කරේ එහෙම වුණොත් ඉතින් කන්දෙන් පල්ලෙහාට නගම ඉතින් මු යනවනේ. හරි. දැන් මම මෙතන අල්ලන් හිටපු නිසා යම් කිසි තැනක නැවතුණා. මම අල්ලන් හිටියේ නැත්නම් ඉතින් මේක දිගටම කොහේ හරි ගිහිල්ලා නැවතුනේ යනවා. හරි. ඒක නිසා unstable condition එක කියන්නේ unstable condition එකේදී යම් කිසි තැනකදී ආශ්‍රයක් මෙයාට equilibrium condition එක වෙන්න පුළුවන්. නමුත් ඒක කොතනද වෙනවද කියලා අපිට කියන්න බෑ. හරි. ඒක තමයි difference එක. Is it clear? If you got the difference between unstable and neutral condition, please let me know. Please raise your hand. Tusan. There is a difference between neutral and unstable condition. Neutral and unstable condition. Again, you have to clearly understand this. So this is the neutral condition. If you give a small displacement, this object will come to the equilibrium condition. Come to the equilibrium condition at that position. If you give a small displacement, again, it will be in equilibrium condition at that position too. If you give a small displacement, again, it will be in equilibrium condition at that position too. Therefore, this object can be in equilibrium condition in any position. In any position. And there is a difference between unstable and stable, unstable and neutral condition. Therefore, this is stable. To have equilibrium condition, why not? G is lower than P. G is lower than P. Yeah. Then the second one. The second one is uh, unstable condition. Unstable. Unstable equilibrium means the opposite side, opposite में one होते हैं, opposite part. हाँ, मम्मी का प्रोडक्ट है ना मम्मी का. Kenapa lagi? G should be lower than P putih to have a stable condition. Then, if we need to have unstable condition, then G should be higher than P putih. G should be higher than P. G should be higher than P. So here G, here P. This is the pivot point. Therefore, rotation is around pivot point. The rotation is around pivot point. Rotation here is around pivot point in what? Therefore, if I give a displacement like this, if I give a displacement like this, what will happen? Now G is here. displacement in epithetic. Therefore, towards the direction of displacement, W creates a moment. Therefore, moment by W into the same direction. Therefore, the moment by the W is into the same direction of displacement. Therefore, it will rotate into the direction of displacement. Therefore, to have a stable condition, definitely G should be higher than P. Definitely G should be higher than P. That means it should be above the P. Is that clear? Huh? Yeah. Then the third one, neutral condition. With that neutral condition, G and P should be coincide. That means overlap. They should be at the same point. G should be overlap with P. So, you know now there's a rotation. Now there's a rotation about P. If there is a rotation, if there is a rotation, it should be around P because P is the pivot point. Therefore, if you want to take the moment, you have to take the moment around P. But the thing is, the weight is at the P. If the weight is at the P, that means the distance to the weight will be 0. Therefore, moment is equal to 0. Therefore, even though you have rotated this object, the moment which is created by G is 0. So if there is no moment, then there is no rotation. That is the reason this previous book is not rotated when it is in neutral condition. Because it won't be rotated because there's no moment. To rotate, there should be moment to put it. No moment is 0. Is that clear? If it is clear, please raise the hand. Neutral condition. No moment is 0. Right? Therefore, although we have rotated, the moment is 0. Therefore, rotation about P therefore as G over P, then moment of W about P is 0. Therefore, no moment around the pivot point. Therefore, no moment around the pivot point. Therefore, no rotation about the pivot point. Therefore, no rotation about pivot point. Therefore, no rotation about the pivot point. Megad Okay. හරි. හරි. දැන් පොඩ්ඩක් කියන්න බලන්න. අර සිදු බලන්න මේ දැන් ඔයා හිතන්න බෝට්ටුවක් හරි ට්‍රක් හරි ගන්න යනවා කියලා. මොකද්ද මොන වගේ ඉක්විම් කන්ඩිෂන් එකක්ද මේන්ටේන් කරන්නේ? හා මොකද්ද මේකෙන් හොඳම ඉක්විම් කන්ඩිෂන් එක ඒ වගේ දෙයකට. හ්ම් බෝට්ටුවක් හරි වගේ දෙයක් හදනකොට මොකද්ද හොඳම ඉක්විම් කන්ඩිෂන්? Suppose now we are going to build a boat or ship. Then what would be the most suitable equilibrium condition for a boat or ship? Is it stable or neutral? Definitely, we can reject unstable. Look, the stable condition. So why didn't you choose neutral condition? I have a neutral condition use करना है. I neutral condition choose කරන්න නැත්තේ. ඒක හොඳ එකක් නෙමෙයි. ඒක හොඳ. ඒ ස්ටේබල් ගන්න මේ ඉක්ලිබ්‍රියම් කන්ඩිෂන් එකේ තියෙනවා. ඇයි අපි ඉක්ලිබ්‍රියම් කන්ඩිෂන් එකේ තියෙන එකක් යූස් කරන්නේ නැත්තේ? I neutral condition use කරන්නේ. Why didn't you choose neutral condition? Because it is a very stable, actually stable way. Stable means there is a very good equilibrium condition. That means equilibrium condition will not lose something. And the equilibrium condition will remain as unchanged. Therefore, why can't we use the neutral condition? Yes. එහෙ වුණොත් වෙන්නේ මේකයි. මූ හැමතැනම මේ ඉක්ලිබ්‍රියම් පුතේ. බැරි වෙලාවත් yes. Yes. ඒ කියන්නේ ෂිප් එක මේ වගේ නිකන් හරි මේ වගේ තිබ්බොත් එහෙම ඌ එතනත් ස්ටේබල්. ඌ මෙතනත් ස්ටේබල්. ආයි හැරෙන්නේ නැහැ ජීවිතේ. මූ අනිත් පැත්තට ගහුවොත් ඒ ෂිප් එක this will be a stable condition. This will be a stable, sorry, equilibrium condition. If it is a neutral condition, the ship will be stable. Ship will be in equilibrium condition at 10 position. Therefore, if it is tilted, then it won't be able to recover. It won't be able to recover. වතුර පෙරදා මැරෙන්නේ නේ. ජීවිතේ උඩට එන්න බෑ. ඉතින් හැරුණොත් තරනවා. ඒ නිසා therefore neutral condition is a actually the object is in equilibrium condition in neutral position පුතේ. But sometimes it is a dangerous stable condition. Dangerous equilibrium condition because the object can be in equilibrium condition at any condition. At any condition. At any condition means sometimes that condition may be good, sometimes that condition may not be good. And therefore, this object can be in a stable condition, in a equilibrium condition, in this kind of scenario too. Therefore, we cannot use neutral condition in some application. මේ වගේ conditions වලදී ඒක පාවිච්චි කරන්න බෑ. හරි. මම වාර දෙකක් තියෙනවා සමහර වෙලාවට පුංචි toys තියෙනවා සෙල්ලම් වල තියෙනවා. ඔය බෝඩ් බේස් එකේ මොකක්ද තියෙන දැක තියෙනවා. ඔය මේ පෙන්ගුයිල්ලා වගේ එක සත්තු ඉන්නවා. උට කොච්චර ගහුවත් ඌයි කෙලිනවා. කොච්චර ගහුවත් ආයි කෙලිනවා. ඒ කියන්නේ අර කොච්චර මේ ටිල්ට් කරන්න නේද තායිසලක අනිත් පොසිෂන් එකට වෙනවා. දැකලා තියෙනවා. හරි. ඒ මොන වගේ ඉක්ලිබ්‍රියම් එකක්ද? මොන වගේ ඉක්ලිබ්‍රියම් එකක්ද? Yes, it's stable, no? It's stable. Right. Then the last topic in this lesson today, and this one, because you are top plane of an object. Suppose now there's an object like this. Now we need to rotate or topple this object. So if we want actually when there's a toppling, of an object, actually what will happen? మేము topple walk. So initially this object touch the horizontal force, touch the plane, touch the plane using its bottom surface. Using this bottom surface, there's a contact between the bottom surface and the horizontal force. And then when there's a toppling, what will happen? When this is a toppling, one side will raise up. And the toppling occurs around a certain point, around a certain point. And again, අපි topple කරන් හැදුවට කොහොම විදිහට මොකක් හරි topple කරන්න හැදුවොත් එහෙම අන්තිමට එයා මොකක් හරි point එකක් වටේ තමයි topple වෙන්නේ. Therefore, if there's a toppling, that rotation occurs around a certain point. That means if you want to topple this object into this side, finally the rotation occurs about this point. The rotation occurs about the point A. And therefore, if there is a toppling, definitely there should be rotation. If there's a toppling, there should be a rotation. Otherwise, there's no toppling. Therefore, toppling means that it's a rotation. Therefore, definitely, if there's a toppling, there should be a rotation. Now you know, if there's a rotation about point A, definitely there should be a rotation about point A. Rotation means if there's a rotation, it is very clear. Definitely there should be a moment. Therefore, if there's a rotation, or if there's a toppling about a certain point, definitely there should be a moment. About that point. Otherwise, the object will not be rotated. Is that clear? If it is clear, please raise the hand. තේරුණා තුස්සන්නේ. Toppling එකක් වෙන්න නම් අනිවාර්යෙන් පුතේ topple වෙන point එක වටේ rotation එකක් වෙන්න ඕනි. Topple වෙන point එක වටේ rotation එකක් වෙනවා කියලා කියන්නේ අනිත් topple වෙන point එක වටේ moment එකක් තියෙනවා. Now දැන් බලමු මොකක්ද දෙක තියෙනවා recommend කියලා. Okay, look at this one. So initially this full surface touched the object with it, therefore the reaction force is here. then there's a right here. Now, once we try to topple this object, then what will happen? The touch location, that means contact, the contact between the object and the surface, the contact between the object and the surface reduced to a single point. Now there's a touch between the object and the surface at this location only. At this location only. Therefore, initially the reaction force at this position, now this reaction force is shifted to this point put it. Now the reaction force is exerted from this location. Is it clear? Now the reaction force is exerted at this point towards the upward direction. If it is clear, please raise the hand. Now look at this one. Now, if there's a top plane, they make a product. Now, if there's a top plane, definitely there should be a rotation about point A. That means there should be a moment about point A. To have a moment about point A into the direction of rotation. Definitely the center of gravity should be located at this position. The center of gravity should be located towards the direction of rotation. මේ rotation එක තියෙන පැත්තේ තමයි center of gravity එක තියෙන්නේ. ඒ කියන්නේ ඔයා මේ පැත්තට නම් rotate කරගන්න ඕනි පැත්ත center of gravity එක තියෙනවා. මේ පැත්ත නම් කියන්නේ left hand side rotate කරගන්න ඕන අනිවාර්ය ඒ පැත්ත තමයි center of gravity එක තියෙන්නේ. Therefore, if there's a rotation about point P, definitely the center of gravity should be into the left hand side. Means into the direction of rotation. Then this will create a moment about point A. Then the object will be toppled. Is the topic that if it is okay, please raise the hand. So at this position, the object will be rotated. Because now G is shift into the left hand side. The G is into the left hand side of this polygon. And but when the object is about to rotate, 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 W and R should be overlapped. W and R should be overlapped. W and R should be overlapped. And once they are overlapped, then if you shift, and once they are overlapped, and if you rotate, if you give a displacement, if you give a little displacement towards the left hand side, what will happen? Then this kind of scenario can be observed. මොකද වෙන්නේ? මෙයා ටිල්ට් කරන් එනකොට මොකද වෙන්නේ? මෙයා ටිල්ට් කරන් යනකොට මොකද වෙන්නේ? There is an occasion. There's an occasion where the gravitational force and reaction are overlapped. If we give a little more displacement, into the same direction, then this gravitational force will shift to the direction of rotation. Then it will rotate. Then it will start rotation. Is that clear? පැහැදිලි නේද උස්සන? තේරුණාද උස්සන? This is figure 1 පුතේ. This is figure 2. Figure 2 and then ඊට පස්සේ figure 3 අදින්න. මම මේක පොඩ්ඩක් මාර්ක් කරලා යන්නේ. Figure 2 and figure 3 අදින්න. Okay. මේකද? You can do this one. Okay, right under this, right under this. A top plane occurs, a top plane occurs around a certain point, around a certain point. When the object is tilted, when the object is tilted, the contact area will be reduced to a single point. The contact area will be reduced to a single point. Now, the contact reaction comes, sorry, now the contact reaction, now the contact reaction is exerted at this position, at this point. Now the contact reaction is exerted at this point. Write it into the para. If the object rotates, if the object rotates about that point, if the object rotates about that point, there should be a resultant moment, there should be a resultant moment about that point. Therefore, the weight should create a moment. The weight should create a moment about the point of top lead, about the point of top lead. Write it in the para. Therefore, there's there's occasion where the center of gravity and R are overlap. There's an occasion where the center of gravity, sorry. There's an occasion where the weight and R are overlap. At that position, the object is about to topple. The object is about to topple. Underline that sentence, Putri. Underline that sentence. Underline that sentence. Okay. Then write in another para. If a little more displacement is given, if a little more displacement is given, the object will start to topple. The object will start to topple. Yeah. Is that okay with you? So what is the question issue? I did not get that thing. If a little more displacement is given, the object will start to topple. If a little more displacement is given, the object will start to topple. Hey, Ronald. Extended means you means why I draw this line this much. Hmm? Still, I did not get your question. Extended means you means why did I draw this line this much of height? Is it? Hmm? Why did I draw this line this much of height? Yeah, that is not a problem. Actually, I just want to overlap these two. I just want to overlap these two. That is the reason. And that is the reason. You can draw this line up to this. No need to worry about that thing. And actually, I just want to overlap these two. That's why I draw this line, this much of height. Okay. No need to worry about that thing. Right? ඒ ලයින් එක ඕන සයිස් එකක් එන්න ඕන. ලයින් එක මොඩි වෙන්න ඕනේ. අපෝ ඕන තරම් යන්න දෙන්න පුළුවන්. ඒක ප්‍රශ්නයක් නෑ. මොකද මම මේක ස්කේල් එකකට දෙන්නේ නැහැ පුතේ. මේක ස්කේල් එකකට දෙන්නේ නැහැ. ස්කේල් එකකට දෙනවා නම් ප්‍රශ්නයක් එනවා. අපිට ඒක අවුලක් තියන්න ඕනේ. Okay, do you have any other questions regarding to this lesson? So this is actually our lesson is almost finished, but we have to do some questions. But I have sent you the EQR paper there. Therefore, you can try that one. Actually, there's some actually the time is mentioned there. Therefore, you can allocate that particular time period and do the paper. Because I need to discuss the thing in our next class. Therefore, before you come to the next class, please do the equal question. Then we can complete this lesson. Actually, theory part is completed. Have to do some questions. Therefore, I'm not going to give some time to do the question in next class. Therefore, please do the questions as a homework, then come back to the next class. So if you can send that to me before next Sunday, it will be much better. And therefore, do you have any questions regarding to this lesson? Other listening ප්‍රශ්න next Sunday when කලින් equal එක next Sunday when කලින් equal එක වන්න. හරි. අපේ term test එක week එකකින් පොඩ්ඩක් postpone කරන්න මොකද last week කරන් ඉවරනවනේ පුතේ. ඒ නිසා අනිවාර්යෙන් අපි exam එක first of June යනවා. first of June 25th කරන්න බැරි මොකද මේ last Tuesday වල කරන්න නැති class එක. හරි. මේ එහෙම exam එක first of June යනවා. Then next Sunday we will do EQR questions regarding this lesson. Then as a second session we will do work and energy. And do you have any questions regarding to this lesson? No. Okay. Alright. Then we can complete today's class with it, everyone. Then good morning, then good night, good night, Thiran. Okay, good night, Pute. Everyone. Okay, thank you. Welcome. Welcome there. Thank you, Pute. Yeah, come with it. Yeah, come with it.